In these 3 hours of data engineering masterclass, you will learn about what is data engineering lifecycle, data generation and storage, database management system, data modeling, SQL versus NoSQL, data processing system like OLTP versus OLAP, ETL pipeline, extract, transform, load, data architecture. So I will give you the complete guide on how to build the architecture from scratch, data warehousing, dimensional modeling, slowly changing dimensions, data marts, data lake versus data warehouse, big data landscape, data engineering on cloud, top AWS services you should learn for data engineering. We will understand the real world case study architecture on AWS, GCP data services and Azure data services, and we will also understand the real world case study for both of these cloud also. We will also explore the modern data stack, important tools for data engineering that you should learn, understand Python and SQL for data engineering, understand data warehouse tools like Snowflake, BigQuery, understand Apache Spark with Databricks, understand Apache Airflow and Apache Kafka for data engineering, and many more things. So sit tight, get notebooks, pen and paper, start taking notes so that you can remember for this longer period of time. And before you move forward, make sure to hit the like button and subscribe to the channel if you are new here. Let's get started with the fundamentals of data engineering masterclass. So fundamentals of data engineering. Okay. We'll start by understanding what is data engineering, because if we want to understand the different fundamental concept, we need to have our basics clear. Now, if you have been following me on this channel from like past few years, then you might already know about what is data engineering because we keep talking about this. But if you are seeing me for the first time, or if you are just getting started with data engineering, it is important for you to understand what is data engineering. So let's start with that. Okay. Now we already know, right? Everything that happens on the internet mainly, okay, because this is where the data engineering happens on the internet. All of these are the businesses. Okay, the businesses are, let's say, Amazon. Okay, what is the business of Amazon? Amazon is a e-commerce company. What they do, they give you the ability to purchase products online, okay, from your home. Now this is the business of Amazon. What is the business of, let's say, Netflix? Okay, the business of Netflix is to give you the exclusive content. You buy the premium and they give you the exclusive content. On top of that, they also give you the recommendation and all of the other things. Okay, this is the business of Netflix. What is the business of, let's say, Zomato? Okay, this is a food delivery app in India. You can, from your home, you can order food. Okay, and the order will get delivered to you within like half an hour to 1 hour. Okay, there are multiple companies who are doing businesses on the internet. Now, all of these companies, okay, have certain goals and the visions for the business, right? They want to understand the customer. So understand customer. Why they want to understand the customer? Because so that they can provide better services. Okay, they want to increase their profit. Okay, I want to increase my profit. Okay, this is one of the goal, that I want to increase my profit, understand my customer. They also want to detect some of the bottlenecks they might have in the business. Okay, so improve the process. Okay, improve uh, business process. And like this, there might be like multiple goals a company might have. Now, if they want to achieve all of these goals, they need to understand how these things are happening. And one of the best way companies can do that is by understanding the data. Now, most of the time, all of these decisions are taken by based on the assumptions, right? A business person, let's say, who is working in the shipping department of shipping department of Amazon, okay, he is actually working on the ground and have the knowledge about this particular segment, the shipping. Okay, now he already has some of the business knowledge to take direct decisions on this particular segment of the business. Okay, because he's an expert, he's been working in this particular field for like 15 to 20 years, so he understands what might be the problem. But a lot of times, even as a human, we might miss out on some of the information that we don't know. And the best way to understand all of this information is by understanding what does the data says. You can assume certain things and you can be right for some time. But if you want to be right at most of the time, the best way is to be sure about it. The only way you can get sure about all of these things is by understanding what does the data says. Okay, and this is where the entire picture of data engineering, data science, machine learning, AI, all of this comes into the picture. So let's start by understanding all of these things one by one. Okay, I just planted you the picture. The reason we are doing data engineering or data science on the first place is because companies want to understand. Okay, they want to understand, they want to improve their business, they want to provide the better services to customer, they want to uh, like remove the challenges they might have in the business by using the data, because data gives you the direct answer. They give you the factual understanding rather than you just assuming things. Okay, so this is the understanding of why do we need the data driven system. Now, how does all of these things happen? Okay, we already know this. Okay, at the end we want to have the final outcome. It can be, we already understood, right? Improve uh, business, okay, revenue, and it can be like recommendation and overall thing. So these are my business goals. Okay, these are my business goals. uh, Business goals. Okay, every single thing you do in your data ecosystem or in general engineering ecosystem online is for this only. Okay, anything you do should create the value for the business. If even if you use the like the highest algorithm, but if it doesn't impact the final outcome of the business, it is completely useless. Okay, it should help business in certain way. It should help business to save cost, it should help business to improve the processing, it should help business to understand the customer, whatever it can be. If it can provide the final value, then it is useful, or else it is completely useless. Okay, so this is very important. Everything that you do, it should create the value for the business. If this is clear, let's start by understanding the entire pipeline of data engineering and the entire pipeline of overall internet system. Okay, before we just understand the data engineering life cycle, we need to understand how different things or different fields come together to make the complete system. Okay, so we have the company. This is my company over here, which is let's say this is my company. Okay, and the companies are doing like it can be Amazon or whatever. We'll take the one example. Okay, now at the front end we usually have the application. Okay, this is my application. Okay, this might be my mobile, there's a button, and this is my application, and user interacts with the application. Okay, I'm the user. I have the Instagram installed in my phone, I have the Facebook, I have whatever. Okay, I might be using LinkedIn. I have the application, and whenever I interact with this application, a data gets generated. Okay, whenever I click on any application, whenever I like something, when I comment something, every single thing that I do, even if I go to Amazon, if I click on certain product, every single thing, okay, every single thing generates a data. Okay, now all of these data will get stored, okay, inside the DBMS. Okay, these are called as a database management system. Now there are different types of database management system we will understand in this video, but just try to understand every single thing that we do, it gets stored inside a DBMS, database management system. Okay, now these systems are usually designed for storing this kind of data, right? You can store this data easily. uh, there is something called as a CRUD operation. Okay, which is called as a create, update, read, and delete. We'll understand that in the further down the video. But all of these databases are called as a relational databases, especially designed for storing all of these things. Now, once you store all of these things, all right, we have the data available. Now, data might be coming from the multiple places, but let's understand, we from the application, our data gets stored inside the DBMS, and from there, our entire data engineering pipeline start. Okay, the data engineering happens, data science happens, machine learning or data analytics might happen over here, and then there might be final dashboard. Okay, there might be some dashboard or some charts available here. Okay, businesses use this, or there might be machine learning model. Okay, so this is like a robot. Okay, I'm bad at drawing, but this is one of the robot or a machine learning model who might help in understanding all of these different things. Okay, just trying to like just trying to plant a simple picture of the entire ecosystem. There are many different things that goes here. Okay, the application development, there might be DevOps who might be deploying application, but in general, from application to DBMS, whenever we have any data available, okay, this is where the internet companies come into the picture, because you can store all of the data inside the DBMS, database management system. Okay, and then you can utilize all of these data for this kind of workload. Okay, after once you have the data generated, this is where the data engineering start, because without data you don't have data engineering, data science, machine learning, because they work fundamentally on the data. If you have the data, then you can do something about it. If you don't have the data, then you can't do anything about it. Okay, so fundamental concept of data driven system is having a data generation in place, and this is what the data generation looks like. Okay, you have the application, the data is getting generated. There might be other things such as sensor data. Okay, a truck is moving from one location. Okay, this is one of the truck. Okay, that is moving from one location, and it is going to from A location, it is going to B location. Now in between, from B, it might go to C location. Okay, now truck goes from here to here to here. Okay, it goes from here to here to here. Now we need to capture all of this data, and all of these data get captured by the sensors, right? Truck might have sensor, but just like we're interacting with the application, trucks might have sensor. Just like this, we have the stock market data, we have data coming from the numerous places. Okay, so we understood how the data is getting generated, sent to the system, and all of the other things. So this is the fundamental concept of data engineering, which is where the data engineering sits on the first place. Okay, as we move forward, we will understand all of the different parts of data engineering individually, but just try to understand where the data engineering really fits into the entire cycle. Okay, it is between around the application development and the database. So whenever your data gets generated, okay, it is over here. This is my application side, and this is my data science, machine learning, dashboarding side. Data engineering sits between. It is kind of like a plumber. Okay, I'm connecting one thing to the second thing by transforming data and some of the other things that we will understand, and then I pass it the data to the next end. Okay, I get the data from one source and I pass my data to the next source. How do data engineers do that? What are the different features, functionality, frameworks, all they use? We will talk about all of these things one by one in this video, so don't worry about it. Okay, just I hope you understood the basics till now. Okay, so now that I understood where the data engineering sits, what is the role of data engineers in this space? Because application developers, so we have the software engineers. Okay, the general role of software engineering is to develop the app, web app. It can be web application, it can be working, writing code, developing or deploying some of the things. Okay, then we might have the DBA. This thing can also be done by the software engineers in the smaller company, but if you are working in a big company, DBA is a database administrator who develops the data, right? They build the different tables, they build the different columns, all of the other things. These are the built by DBAs usually. Data engineers can also do that, or the software engineers can also do that. Depends on the company's size and your job profile. But let's understand, we might have a DBA who will build a database. Okay, so this guy will be writing database. Now, what who do we have? We have data engineers. Okay, data engineers. The role of data engineers, there are many different things. I'll tell you just, it's to write the ETL pipeline, extract, transform, load. We have a dedicated section on this, but ETL is basically we extract data from one end, we transform that data, and we load that data. Okay, then it can be also building a databases. So databases or data warehouse, warehouse. Okay, database or data warehouse, or data engineers can also do that. Okay, they can build a relational databases or dimensional modeling. We'll understand that. Working with the big data and processing all of these data using Spark, Hadoop, using different frameworks or Kafka. Okay, to process the batch data or the real-time data, we can also do that. Data integration. So again, data is coming from the APIs, data is coming from the sensors, data is coming from the RDBMS. So we want to integrate all of these data. So data engineers have the responsibility. There are other responsibilities such as quality check of the data and the governance, how to organize all of these data properly. So these are the core use case of the data engineers. Now after that, we have data science people. Okay, data science or data analyst. Okay, usually the difference between data science and data analyst is basically, data analyst usually answers questions what has happened in the past. Okay, how can we like, what was the revenue of this particular product last year compared to last 5 years, right? They are trying to find the pattern from the past and find some of the answer. The role of data science is to predict what can happen in the future, right? We did a product sale of this particular we did the product sale for this particular product, x amount for the last 1 year. What will be the product sale for this particular product for the next 6 months? This is what the data science answers, right? They try to predict what will happen in the future based on the past patterns. And we have the machine learning engineers, they can basically automate all of the other things. So on Amazon we have like recommendation system, right? All of this recommendation system is done by machine learning engineers. They deploy the machine learning models onto the production system so that a system can learn by itself and generate the right output for the user. So you can predict what is happening inside your system, or you can predict how the users are behaving and recommending them the right information. Like on Instagram, you go to reels, you see the right reels as per your interest. Okay, they don't directly recommend you the random things. They also recommend you the random things just to understand do if you like it or not. So they're just trying to train the machine learning algorithm based on your usage on the application. Okay, now the difference between DS and ML is quite thin. Okay, you might see a data science person might do the ML work, or ML person might do the data science work, but in the larger organization they might have the individual work to do. Okay, they have the core responsibilities, but in the smaller organization they might have to do all of these things by themselves. So do not get caught up in the title like, oh, what does a data science person do, what does a machine learning engineers do. Just try to understand the core responsibility from the top level in the actual organization. When you go to the work, okay, when you start working, you might have to do everything by yourself because the role is just a name. Okay, but this is the like the core distinction between all of these roles. There are other roles such as DevOps, data ops. These are just the fancy names, but on the fundamental level you might be doing the similar work. Okay, so we understood what is data engineering. Okay, the role of data engineering is to take data from one source. Okay, it can be any data from like RDBMS API, do some transformation and pass this data to data science or machine learning guy so that they can build dashboard, or they can build a machine learning models. Now all of these things that we do, okay, there is a proper uh, approach to it. Okay, you can't directly get the data from one source and directly push it to the data science person. There has to be a step by step approach that is designed properly so that the entire pipeline that you generate has some purpose to serve. Okay, and this is what we will understand. Okay, so this is what we call as a data engineering life cycle. This is taken from this book, Fundamentals of Data Engineering. I have recommended this book to so many people, and it is one of the best book if you want to understand the fundamentals of data engineering. A lot of materials that I have learned about the fundamentals is from that book only, and some of the materials I've also added in this video also, so you will get the understanding. Okay, so the first step is here is that the data generation. Okay, now this thing we already talked about, right? Data generation. Data is getting generated from multiple places. We already know data comes from what? APIs. Okay, RDBMS. It comes from sensor. It comes from analytics. Analytics like Google Analytics or all of the other things. Okay, so data is coming from multiple places. Now all of these data that are coming from these different places, we need to aggregate this data, okay, together and ingest it into the system. Okay, now this is what the next step is over here. Let me just remove this. Okay, this part. Okay, the data ingestion. Okay, we are getting the data generated from one places, then we need to ingest this data to one particular system. The ingestion can be setting up the connection with the API, setting the connection with the RDBMS, make building a system that can read the data from sensors and then automatically ingest this data to our data engineering system. Okay, we will understand what this entire data engineering system feels like when we actually look at the project example. But this is the fundamentals. Okay, we have the data generation and that data is getting ingested into some kind of system. Okay, and we just build a programmatical connection between these. So uh, whenever any data gets added to the RDBMS, okay, it should automatically get ingested into our system. So there are multiple approaches to do that, but this is what the fundamentals. Once the data is getting generated, we ingest this to our system. Then the data that got ingested, that will get stored. Okay, there is some kind of storage layer we have. So every data that is coming from the multiple places. We have to store all of this data at some location. Okay, it should get stored at some location at least. So this is where the storage happens. Okay, we are storing this data at some location. Now, between this ingestion and the serving, okay, serving is basically we are serving this our data to machine learning, analytics, and reporting. Okay, the thing that we understood over here. Okay, after the data engineering happens, we have data science machine learning person who is building a dashboard or who is building a machine learning model. The same thing here is that this is the part. Okay, the machine learning or the analytics we have, reporting, dashboarding, all of these things happens over here. This is where the data is ingested and this is where the data is getting stored. Okay, between that is the core of data engineering, that is called as a transformation. Transformation is basically the set of business logic, all right, that we need to convert our raw data. This is usually we call as the raw data because it is coming from the system. Okay, so this is my raw data. This is my raw data. Okay, here this is my transform data. When we serve this, okay, when we serve this is the transform data, this is the raw data, and everything that happens in between this and this is called as a transformation. Transformation is a set of business logic and it can be anything. Okay, so consider this example. Let me just explain you this part. Now we have a data coming from API. Okay, I have a data coming from API and I have a data coming from RDBMS. Okay, now in both of the data I have a date column. Okay, I have a date column. I have a date column, and the format of date in API is YYYYMMDD. Okay, it is like uh, 2024, month is 06 and the day is 01. Okay, the first, I think it's June of 2024. The data is some date format is something like this. Now in DBMS, okay, the date format is like MMDDYYYY. Okay, something like this. It can be like 01 or 06, sorry, 01 and 2024. All right. Now we have a date coming. Now the what we need to do, we need to join this system because at the end we need to find the analysis. There might be some ID column here, okay, and there might be one more ID column available over here. We need to join these two data together. Now when do we join it? Okay, when we join data coming from API, this might be, let's say, product date. Okay, this is a product date. Okay, and this is a order date. It can be anything like this. Okay, now when we join this information, we need to transform this data into one particular logic. All right, that can be formatting as this particular format or this particular format. It can be anything. This is the decision that business people or you can take, right? I want to transform this data based on this format only. So any information that is coming from any other sources, okay, it should be transformed into the YYMMDD format for the date. Okay, so if we are getting this data after the transformation block, okay, so we will have our transformation block here. I will have my transformation block. Okay, these data will go inside this and this. Okay, transformation can be done by Python, PySpark, Spark, Scala, whatever it is. Okay, we will understand all of these things. Okay, how do we do the transformation? And at the end of this, I will get the data into YYYYMMDD. Okay, the date values will be converted into one single thing. This is what we call as a transformation. Okay, this is the one example, but transformation can be anything. Okay, it can be removing duplicates value, it can be removing the null values. Okay, it can be aggregating the data, it can be merging two data, it can be like generating the new column based on the two different columns, concatenating. It can be anything. Okay, you can be filtering whatever it is. The transformation is basically a set of business logic that you have to write inside the code or inside the SQL query or use any tool to do that, to generate a suitable outcome so that data science person or the machine learning person can build a model or build a dashboard to find the relevant answer. Okay, so as a data engineer, my role is to organize the data into the proper structure so that we can easily visualize this or we can easily understand what is going inside the data. So that is my job. I want to make the data into the proper structure. and that usually happens onto the transformation layer. Okay, now that we understood, okay, what is going on, we are getting data generated from the one source. It can be many source, API, sensors, whatever. Okay, all of these data are getting ingested into one of the system. Ingestion basically means making a connection in such a way that anytime a new data that is getting generated, we automatically fetch this data, okay, and store it inside our storage system. Okay, this is what we understood. Now, once we have this data available, we need to make sure the data that is coming from all of these different systems, they pass through a certain transformation logic so that our data gets structured. Once that is done, we serve this data to a user. A user can be machine learning engineer, data analyst, or someone dashboard expert, can be anything. Okay, they are using this data so that they can understand, build machine learning model. This is the entire data engineering lifecycle that we are talking about. Okay, there are some undercurrents that we will understand in further video, so don't worry about it. But I hope you understand the complete data engineering lifecycle from the fundamental point of view, because this is really important, right? uh, you can use any tools, right, to do all of these things, but if you understand the fundamental side of it, then it doesn't matter which tool you use, you already know what needs to be done. So you can pick the shittiest tool in the market, okay, and still make this entire pipeline work. Okay, that is the power you have as a data engineer, because if once you understand the fundamentals, you don't really need to know anything else. You can learn tools within 30 minutes. Okay, it doesn't take time to learn any new modern tool. It's very simple. Even to learn Spark and how to write the Spark code, it is very easy. Okay, you just need to understand some of the functions and execute. There are some angles to the Spark, such as the internal and the understanding executor driver, all of these other things that you need to understand to become a better engineer. But to do this entire job, it is not that difficult. Okay, you just need to you just need to understand how to make connections between system and execute the entire thing. Okay, now that you understood, now we can go forward and start talking about the individual components, right? How can I do the generation? How can I do the ingestion? What can I use for the transformation? How can I do the serving? What is the use for storage? Okay, machine learning, analytics, reporting, every single thing that we will talk about, and we will also talk about this part in the further down the video. Okay, now this is understood. Let's talk about the data generation and data storage one more time. All right, so we got the basics till now. Data is generated from the multiple places. Data is coming from the transactional system. Okay, these are called as the RDBMS. Okay, there are multiple types of transaction system that we will talk about, so don't worry about it. Data is coming from the IoT devices, so we have the IoT device. Okay, it is coming from there. It is also coming from web and social media. Okay, that we understood. Data is coming from the logs and machine data. Okay, this is also important because again, uh, we are running the technical machines, so they are also generating logs, and if we want to improve the utilization of this technical machine, we can also use this log data to understand what is going on and save cost over there also. Okay, then we might have the some API data, API or the third party data. Okay, third party data, sorry for the bad handwriting, but this is where the data is getting generated. Okay, now once we have the data available, we have to store this data. Okay, the storing of the data is basically we store it into the relational database. uh Database. Okay, this is same transactional data and relational data, so you can from the application to RDBMS, data is generated. Okay, this is where the data generation, you can also put the RDBMS into data generation because it is connected to the application. Okay, and you can also put it on the storage layer because data is getting stored inside the RDBMS. So you can also keep it generation and storage, doesn't matter. Okay, because from the data engineering point of view, we usually consider RDBMS as a data generation source. Okay, from the application point of view, we are usually consider it is as a storage layer also. Okay, so quite tricky to understand, but it's simple. You can consider RDBMS as data generation and the storage also. We also have a NoSQL database. Okay, NoSQL database that we will understand. Have a for data storage, we have a data warehouses. Okay, this we are talking about this particular thing. Okay, the thing that we understood about the storage. Okay, generation and ingestion. is this part. This is the data generation, okay, and the storage that we talked about over here is this part, okay. We can store our data into the RDBMS, NoSQL, data warehouse, or object storage. Object storage. Object storage can be like S3, Google Cloud Storage, Azure, Blob Storage, all of these other things that we will also understand. Okay. You can also call these things as a data lake. Data lake. Okay. So these are the storage system. We understand the generation, how the data is getting generated, and where our data will get stored. So, okay, this is what we understand. Now let's understand about the DBMS. Now, okay, the thing that we were talking about, transactional system and RDBMS system, okay, that is used for data generation and data storage. In reality, we use the DBMS, database management software, okay, database management system, okay. These are the systems specially designed for storing your data into the structured way so that you can easily query your data. Now understand this, okay. You can also store your data into the MS Excel or the Google Sheet if you already know, right? You have the column here and the row and column format, so you can store your data. But if you want to store, let's say, the millions of data or billions of data, and if you want to find a specific record, MS Excel will not be able to handle that, okay. Because if you want to find a specific record from, let's say, the 1,000 line or the 1 lakh row, okay, it will be very difficult for you to do that. DBMS system, okay, are specially designed for this kind of workload, okay. You can store your data and you can easily retrieve, update your data as per your requirement. There are different types of DBMS system available. We have the PostgreSQL. This is the open source. We also have the MySQL. This is the open source. We have the Microsoft SQL Server. We have the Oracles. Okay, these are the enterprise level. Okay, if you want to get started, Postgres and the MySQL is the easiest to get started. Now, to work with all of these system, we have a language. Okay, we have a language called as a SQL. This stands for Structured Query Language. Okay, now this is the language that we use to communicate with the database. You might already know about this because you've been following me or you have heard about somewhere. But if you are new to data engineering or just in general data space, SQL is the language that we use to communicate with the database. Now, what can we do with SQL? We can do multiple things. We can select the data. Okay, we have a select query to fetch the data. We can insert the data. Okay, we can insert the data. We can update the data. We can delete the data. Okay, all of these data are getting stored inside the table. It looks something like this. Okay, table will have a column name, okay, and the actual data stored inside this. So this is where all of the actual data is getting stored. The data that we talk about, like, it can be let's say this is our data, okay, student data, okay, and there is a table. Student, what student will have? Student will have ID, okay, student will have name, it will have age, and it might have let's say city where the student lives. So ID can be one, name can be, let's say, Darshil, okay, age can be 26, and the city can be Mumbai. Just like this, there might be some other person who might be, let's say, Akash, age can be 25 and is living at Delhi, okay. Like this, we have a data stored inside our table, okay. So this is what is happening over here, okay. We can select a specific data, let's say where the student ID is equal to 2, okay. I can select this particular data by writing the SQL queries. I can insert the new data as the ID 3, okay. I can delete this data if I want, okay, and I can update this data. Let's say if I want to update the age or I want to update the name. There are multiple SQL queries. If you want to learn about the SQL, I have a course so you can learn in depth, but this is the fundamental concept of SQL. Okay, now this is what we understood, right? This is the SQL that is used for working with the uh, this DBMS system. This is the language or a scripting language that you can call to work with the system. All right, now we have a concept of data modeling. Now this is where we are slowly diving into the data engineering fundamentals concept one by one. Okay, we have like cleared out the foundation part of the data engineering. Now we are diving into the individual concepts that are important for you to understand the entire life cycle. Okay, data modeling. Now see, whenever we are designing any application or whenever we are thinking to build or store our data, we need to design a data model. Data model is basically a visual representation of how our data looks. Okay, so we will take one example. Okay, let's take the example that we all understand, which is the Amazon. Okay, we are building the data model for the Amazon. Now, just use your general knowledge, okay, and common sense to think about what information will Amazon store. Okay, data modeling is basically we are charting out, or we are building a visual representation of how our data will get stored inside the RDBMS. Okay, this is the entire goal of it. Okay, so I need to think about what kind of tables or what kind of data that I want to store for my system. Okay, I want to store in the Amazon, right? I might be storing the information such as about the orders. Okay, I'm storing about the orders. I might store about the users. Okay, users who are on my website. Orders, then the product. I am storing about the product. Okay, what else? I might store about the payments. Okay, okay. What else? What else? Shipping information. Okay, shipping. I might store information about the sellers. Okay, sellers who are selling on my platform. And like this, there might be hundreds of tables in actual Amazon might have, right? But this is the basic table. Like I say, I'm starting my e-commerce company and I'm designing a data model from the scratch. Amazon doesn't exist, nothing exists, and I'm the first person who is starting the e-commerce company in this entire planet. Okay, and I'm thinking that okay, I'm going to be designing my data model, and initially it will have some kind of tables. Okay, these are the information that I want to capture for my system. Okay, this is we are talking from the application side right now. Okay, so we are slowly going onto the data engineering one by one. This is all of these concepts you really need to understand if you want to become a data engineer. So I'm going step by step to make you understand each and every single concept. Okay, so we have the orders, users, product, payment, shipping, and sellers. Now let's say I'm satisfied with the all of this information that I want to capture. What I will do, I will first design a data model for this. Okay, okay, it will be look something like this. Okay, so first of all, I have the orders. Okay, I will create a order table. This is my order table. Okay, order. Now order will have any lot of things. So first of all, I have the order ID. Okay, order name. Okay, order date. Okay, let's be satisfied with this. Then we have the user. Okay, I have the user available. User will also have the user ID. Okay, we'll also have the name, age, address, and all of the other things just like the normal user have. Okay, then we have the product. Okay, now we have the product information. In the product we have the product ID. Okay, this is the primary key or the unique key to understand which product is it. Then we have the product name. Okay, product category, product description. Okay, product quantity, can be have product weight, product unit size, lot of things that we can store. Okay, then we have the payment. Okay, so payment id, payment amount. Okay, payment date can be there. Okay, so we'll just keep the three things. Then we will have what, shipping. Okay, so shipping id, shipping date. Okay, just keep these two. And the sellers. Okay, this is sellers. We will have the sellers id. Okay, seller name, it can be age, location, or whatever it is. Okay, so we just kind of like figured out the tables that we want for our database. Now we need to join them. All right, so all of these tables only make sense if we have a relationship with each other, right? So how does the relationship happens? Okay, a user, we have, okay, user orders a product. Okay, so order will have all of the single information that is getting ordered on the platform. Okay, so on the order we also have a user. Okay, user id, this is a foreign key, this will be joined over here. Okay, a user can order a product, user can order the multiple or single product. So we will have information about the user ID. A user ID has ordered a product, which product it ordered. Okay, so we also need to add a product ID. Okay, product ID. So we will join this particular thing over here. Okay, it is joining. Let me just change the color for this. Okay, so we understood that user will order a product. Okay, product ID will be over here. Okay, so user, so in the order table, which user ordered the product, okay, which product that particular user ordered. Okay, then this is done. Okay, like this is a user and product. Because we can also add a payment information, such as, let's say if I want to add a payment information, it can be added over here, the payment ID. Okay, and then I can also track down the payment. Okay, so the payment can be also tracked down easily over here. So in the order, what was the payment ID? So if you want to understand how much payment that particular user made, we can also do that. So this is what we can add here. Okay, then in the shipping, what do we have? We have the connection ready. Then for the seller, okay, which seller is selling which product? So we can also add the seller ID over here. So let me just get the right color. We can have a seller ID inside the product ID, so we can understand which seller is selling which particular product, and then we can make a connection between them two. So for the seller ID, I have, okay, not this one. After this, what do we have? Okay, a seller. Okay, this is a seller product. This is a seller information. He's selling a particular product, so we can also make a connection between these also. So what we will do, we will add information about, let's say, below the product. Okay, I will just use a different color to show you that there will be a seller ID, just to understand which seller is selling that particular product. Okay, and then we can make a connection between this seller ID. Okay, from here, okay, it will go, it will come over here, seller ID, something like this. Okay, but in general, and then we might have the shipping information. So shipping will have the information about the order ID, which order is getting shipped. Okay, so we can join this particular thing over here also. So all of these tables will be connected together. Again, this is the worst way to draw this particular thing, but I just wanted to show you the fundamental side of it. Because if I just show you the picture, okay, you if you just search on the Google that data model picture, you will find a lot of data model. Data, so in reality, a data model really looks like this. There are some applications such as draw.io, or there are some specific application for database to make this kind of diagram. Okay, and I teach all of these things in my SQL courses. So if you want, you can check the description if you want to know more about it. But this is the fundamental concept of data modeling. I go in depth in my courses, but I just wanted to give you the good overview. Okay, now we understood the data modeling. This is we usually call as a SQL table. Okay, SQL, because these are the relational databases, they have a specific schema defined. So this is the data model. Now in this data model, every single information has some kind of schema attached to it. The schema is basically the data type. So let's say order ID will be the integer information. Okay, order ID will be the, let's say, uh, order ID will be integer, order name will be string. Okay, order date will be the date value, or user ID will be the integer again. Just like this, each and every single column has some kind of a schema or the data type attached to it. Okay, this is called as a SQL, or the relational database table, because it is properly structured, every schema is properly defined. So, and you use the SQL queries to work with it. After that, we have a something called as a NoSQL database. Okay, in SQL we store our data into the column and the row format, but in the NoSQL database we can store our data into a different type of format. One of the format is the key value. Okay, so if you know the basics of Python or the JSON, it's something like this. We have the ID, okay, and there will be a value attached to it. Okay, ID 1. Okay, then we will have the name. Okay, and name will be, let's say, Darshil. Okay, something like this. And the age will be, let's say, 26. Okay, all of this information will be stored into the key and value. So if you want to find, like, say, particular information, you can just search it by the name, age, or something like this. Okay, Then we have the column family. Column, all of this data is actually stored inside the column. We have the document, we have the graph data. Graph data is used for the representation. We don't want to deep dive into it. I just want to give you the overview that this kind of database also exists for some kind of workload. Okay. After this, these are usual comparison that I want to talk about. SQL versus the NoSQL. Okay. SQL is a relational. That basically means that the data model thing that we talk about, all of these things are properly stored and have a relationship between them. Okay. As you can see, this table is connected to that one. Order table is connected to shipping. Shipping table is connected to the product ID. User table is connected to the order. They have a relationship between each of them, okay, with the specific primary key and the foreign key IDs. Okay, so this is called as a SQL relational database. Then we have the analytical. These are usually the OLAP, okay, or data warehouses. Okay, data warehouses. This is what we will talk about further down the video, but these are the SQL databases. Then we have the NoSQL. In NoSQL, we have the graph, wide column, document, key value. Well, if you want to understand about all of this, you can just Google it. You will understand most of it. We don't want to spend time on the NoSQL because we will be mainly understanding about SQL. This is what you will be working mainly in the real world also, because most of the data are actually stored inside the SQL databases and you will be using data warehouse. So let's talk about that one by one. Okay. Now, in the SQL only, okay, the two things that we talk about, relational and analytical, these are the two different data processing system, because all the data storage processing, okay, and we want to talk about that. So let me just get that information. Let's do this. So we have two data storage processing system. One is called as OLTP, okay, and second is called as OLAP, OLAP, OLAP. Okay. OLTP means online transactional processing. Okay. And OLAP is called as online analytical processing. Okay. In SQL that we understood, we have the relational and we have the analytical. These are the two things. Relational is usually called as online transactional processing, and analytical is called as the online analytical processing. This is a relational database. Okay, this is a relational DB, and this is the data warehouse. Okay, data warehouse. Okay, and you will be juggling between these two only as a data engineer. Okay, now we are slowly deep diving into data engineering, so pay attention. Okay, now OLTP system has some kind of use case, and OLAP system has some kind of use case. This is not something, okay, OLTP is better or OLAP is better. They both have their own places in the entire system. Okay, now the use case of OLTP, OLTP is usually used for processing transactional data. Okay, it is used for transactional data. What does the transactional data means? It means that when you send money to one person, okay, from your A account, it goes to the B account. That is considered as a one transaction. When you purchase something on Amazon, okay, when you buy something on Amazon, that particular information of the product, that this user purchased this particular product and made payment to this amount, okay, this entire thing is called as a single transaction that is stored inside the OLTP system. These systems are mainly designed for this kind of workload. So when you want to do the fast insert of the data, okay, insert, when you want to do the update, or when you want to do the quick reads of the data on the individual level, okay, these are the best system if you want to do that. Okay, these are like very fast if you want to insert update quickly. We talked about the CRUD operation, create update delete, create read update delete. It is very useful for that. Okay, what is this? Yeah, it is very useful for this kind of workload. So the use case of OLTP system is more on the transaction level. Whenever you have a lot of transaction happenings on e-commerce website or banking, the transaction doesn't only mean about the money transaction. Okay, it can be any transaction, such as if you buy a product, if you if you return some product. All of these are the individual row level information that is getting stored. Okay, but if we want to understand what is happening, let's say if I want to understand the last 5 years of data in the using the OLTP system or PostgreSQL, I won't be able to do that. Okay, and I'll explain you the reason behind it. But for that, we have a OLAP system. Okay, OLAP system, the name literally says that online analytical processing. The reason OLAP systems are good because it is mainly used for analysis workload. So analysis workload. So if you want to analyze the last 5 years of data, you can easily do that using the OLAP system. Okay, let me just explain you this individually so that you have the better understanding. So OLTP system is mostly row based. Okay, so every information that you store, okay, is stored inside the row. So like this is my ID. Okay, this is my name, this is my, let's say, age, this is my DOB, let's say this is my payment that I made. Okay, let's say something like this. Now all of these information are getting stored inside the individual row. Okay, now this is the OLTP system used for the transaction. So this is really good for the row level operation. Okay, if you want to do something on the row level, if you want to update the date of birth, if you want to update the age, delete the particular thing at row level, this is very easy. But let's say if I want to analyze the entire data, let's say this is the payment made for 10 rupees, 20 and 30, and what I want to do, I want to aggregate, and like this there are like millions of, okay, there are like millions of row available like this. Okay, and if I want to analyze this entire data from start to end, what I will have to do, if I want to write the query such as select star from or select sum from payment, okay, from this particular user table, okay, uh, select, I'll just write the query, okay, it will be like select, okay, sum, this is a simple SQL query, payment, okay, from tab from the table name is my user. Okay, let's say if I run this query, the thing is, the way this entire query will get executed, it will first fetch all of this individual row inside the result set. Okay, one by one it will fetch all of this entire row, and then from that entire result set it will just pick this single column. Okay, this particular single column will get picked after this, and then it will do the sum. Now picking the entire column or scanning the entire row from start to end, it is a useless process for this operation. Understand this, right? Because we just want to get the sum of payment. Okay, I just want to get the information about the payment only. Why am I scanning each and individual row? Because this entire database, OLTP databases, are stored on the row level. Okay, every single information is stored on the row. Okay, so if I, even if I want to get the information about the payment, I will have to scan the all of the data from start to end and then just select the one single column only. Okay, now as I said, this is only good for a row level transaction. If I want to update, delete the specific row, it is very good. On the other hand, okay, OLAP systems, okay, let me just draw this. OLAP systems are a column based. Okay, so all of the things are the same. Okay, every single thing that such as the ID, name, DOB, or whatever the age, whatever it is, and this is my payment. Okay, on the OLAP system or the DBA or data warehouse, if I execute the same query, okay, these are the column based. Most of the cases you will find them as a column based. Okay, so all of the single information that is getting stored will be stored like this. Okay, in this case we are storing the individual row, so it gets stored like this. Okay, we will have like first row and all of the information about let me just draw it properly. We will have like one single row available. Okay, one, then we will have the let's say Darshil name, age as 25, and this information will get stored. After this there will be one more row that will attach, so every single thing will get stored on the row level. Okay, over here every single thing we are storing at the row level. Over here it will store every single thing on the column level. So ID will get stored, 1 2 3 ID will get stored, then we will have the name stored inside one single column, and we will have the payment information stored inside the column that says 23 $25 $26, something like this. Okay, so every single thing that is getting stored internally as a column level. Just try to understand and just try to visualize this. So when I run the same query onto the OLAP system, okay, select term, instead of scanning the entire row, okay, instead of scanning the entire thing and then fetching this, okay, it will directly go onto the payment and directly give me the sum. So the useless operation of scanning the ID, sorry for this. So useless operation of scanning the ID or the name is not needed. We can directly go to the payment level and we can directly fetch the result that we need. This is the difference between OLTP and OLAP. Okay. Now understand this. As a data engineer, all right. As a data engineer, you will be taking, okay, this is my OLTP system. Most of the time, OLAP system. You will be taking data from this place, okay, to this place. All right. You will be taking data from OLTP to OLAP. And in between, you already know we will be writing transformation. Okay. The thing that we understood about the data generation, okay, data generation and storage is my OLTP system. Okay, this is where the data is getting generated. This is where I do the storage. This is where I do the transformation. Okay, and this is where I do the analysis. This is where the data warehouse will come into the picture, and the data analyst will write the query to understand the data, and then they will build a dashboard, ML models, AI models, whatever you want to call. They will use this OLAP system, data warehouse, or the storage layer that we will have. We will understand about the data storage again in the future, about the object storage, so don't worry about it. But this is the fundamental of it. Okay, now we are just trying to zoom into the individual component and understand what is going on. Okay, so data engineering is basically, we should take this data and move it to somewhere else. We should take the data from OLTP system, APIs, ingest into the system, do some transformation, apply some logic, and load it onto the data warehouse. Okay, this is the core. Now this is the core of data engineering. Now, but how do we do this, right? You said, okay, you understood every single thing, but how does this entire pipeline happens? We have something called as a ETL, extract transform load. All right, you might already know this. Everyone keeps talking about it. We call this as a extract transform load. Okay, the same thing that we talked about onto the life cycle. Okay, this is some kind of like this data engineering life cycle is one way is ETL only. All right, we are extracting data, we are transforming data, and this is the serving layer, which is the loading data. Okay, that is just a conceptual architecture. Okay, how the things work. This is what really happens in the real world. We build the ETL pipeline. We extract the data, we transform the data, and we load the data. Now we already know about this, right? Where do we even extract all of this data? We extract our data from DBMS, okay, analytics. We extract our data from sensor, APIs, okay. All of these data we extract from multiple sources. Then these data come, okay, and then we do the transformation. We understood about the transformation also, right? It is about like removing duplicates, okay, handle the null values, uh, structured data means get all of the information into the same scale. If one age is stored inside, let's say, the string value, or some another source, the age is stored inside the integer value, we bring it on the integer level. If the data is in a different format, we bring it on the same level, and then we load our data. Load can be on anything. It can be on the data warehouse. Okay, data warehouses are like Snowflake DB. Okay, we have BigQuery, we have Redshift. Okay, lot of different data warehouses, or you can also store into the object storage like S3, cloud storage, Google Cloud Storage, GCS, or the Azure data lake. Okay, we also have that. Okay, this is the core concept of ETL that we will also talk about one by one. All right, now Now, okay, so you understood the upper layer. We did all of this Ramayana just to understand this particular thing, the data engineering lifecycle, the top layer of it. Okay, just the top layer of every single thing that we did till now but just to understand the top layer. Now I want to understand the bottom layer of the data engineering lifecycle, that is the undercurrents: security, data management, data architecture, orchestration, and software engineering. Okay, now these undercurrents are also important. Okay, so this is a security. Just by the name you understand our data should be secure. So that basically means who is able to access our data and the system, right? We need to make sure the right person with the right authorization can only access our data. We should not give the access to our data to every single person that is working in the company. This is the importance of the security. All right, then we have the data management. That basically means data governance. Data governance means we should be able to easily find the data that we need. Think about this, right? I was working at a Wayfair. There is an e-commerce company into Europe and US for the furniture. They had data, like they had tables, more than thousands of tables, okay, in the system. Now if I had to find a particular data where this particular data is stored, we I had to go through the documentation that they created to understand, okay, this data can be found at this particular location. This is what we call as a data governance. Ability to multiple things, ability to find the data, okay, ability to find data, okay. Then the definition, what each and every single column means. Think about like, oh, if you have the thousands of tables, and if you access like one of the table from that pool, and that particular single table will have, let's say, hundreds of columns. And if you want to understand what this particular, what is the use of six column, okay, it is something like the payment gateway ID XYZ, something like that. I don't know what this particular column means. This is the use for of definition, okay. Understanding what is the data, okay, what type of data is stored. This is the very important, the data governance. Accountability, what does this mean? Who owns this data? Who is the user? Okay, did you create this table? Okay, which user did create the table? So I can go to that user and understand. If I don't really understand what is the purpose of this table, I can go to the user. Okay, I am working in the shipping department. I'm an engineer over there, okay, and I created the entire shipping table. Now, if any person from, let's say, order department or the return department want to understand what is going inside this table, they can directly reach out to me. I am the accountable for that particular data. Okay, that is what the accountability means. Okay, then we have the data modeling that we already understood. Okay, data integrity, make sure every data makes sense, every data is into proper. Okay, uh, it is it is basically the data is right. Okay, it should not have any random information. Okay, now data ops. So you might already know about the DevOps. So DevOps is basically to automate the entire process of deployment of your application using the best practices. Okay, data ops is somewhat similar to that. Okay, you monitor data governance, observability, incident reporting. That basically means everything that is happening inside your data system. Okay, every single thing that is getting happening in your data system, you should be able to monitor. Okay, you should be able to report the incident that is happening. Okay, so all of these things should be automated, and that is a fundamental concept of data ops, that data operations. So all of the operation sides of the data, right? When you deploy something, is it working fine? If it is working fine, if it is not working fine, right, I should be able to get the error message. I should be able to observe how my data pipelines are working. I should be able to monitor what is going on. All of this is a part of data ops. Now, data architecture. Okay, we have a detailed section after this about the data architecture, where you analyze the information, analyze the trade-offs, add value to the business by designing the proper architecture for the system. We'll understand this. Okay, then we have the orchestration. This is used for coordination for workflows, scheduling jobs, and managing tasks, right? In data engineering, we have like multiple data pipeline working. Data pipelines are basically the ETL jobs. All right, it is just a fancy name, but it's just extracting and transforming and loading the data at some location. This entire operation is called as a data pipeline. Now, like this, there might be like uh, hundreds of data pipeline might be uh, deployed in the organization. Okay, I need to orchestrate all of these things. Let's say once the first data pipeline completes, I only should run the second data pipeline, because this second data pipeline is dependent on the first data pipeline. All of these things is called as an orchestration. It is used. We have a tool called as Airflow, Apache Airflow, for this kind of workload, and we will also understand about the orchestration as we go in the future. Okay, And then we have the software engineering. Software engineering is basically programming, software design, testing, debugging, right? It's basically you have to apply the best practices of software engineering by you can write the ETL, the transformation job using the writing code. Okay, you should use a design pattern of software engineering for the scalability. You should also use the testing and debugging approaches for the to test your data pipeline also. Okay, so all of these are the fundamental concept when building a data pipeline. You should remember security is important, data management is important, data ops is important, architecture is important, orchestration and software engineering. Okay, just fundamental concept, good to know. Don't really deep dive into it right now. As you move in your career you will understand them one by one. Okay, next thing I want to talk about is the data architecture. Okay, if you want to become a good data engineer you should understand a data architecture, and we will be referring one of the newsletter that I wrote, Data Architect 101 for data engineers. So let's jump into that. So before we move forward, I just want to say that I am re-recording this part of the segment because I was recording this part yesterday and my disk got full. I ran out the space. My OBS stopped recording in between. An entire file that for like 1.5 hour file got crashed. Okay, so I'm re-recording this part of the video just to have like one shot of the video. So if you're still watching this video till here, I'll urge you to at least like this video, okay, because it takes a lot of effort. And do comment something so that it increases reach of this video and it reaches to more and more people. Okay, let's start with the video. Now till now what we have done is like we have understood the basics of data engineering, right? We understood about what data engineering is, where does the data engineering fits in the entire pipeline, the data engineering lifecycle, different parts of ETL, OLAP versus OLTP. So we cleared the basic fundamentals that are required to understand the core data engineering. Now, so we understood the core data engineering aspect that we need to understand. Now I want to take you on a journey to understand how data engineering happens in the real world. From understanding how to build the architecture, how does the architecture is actually built from the ground up, right? How does the thought pattern is developed? How do you understand the business side? How do you understand how to choose the right technology? And put all of these things together and individual components, each and everything. Now we will understand. Okay, so let's start. Now I want to make you understand the data architecture first, because so before we even understand the different parts of data engineering, it is really important that you understand how to build the basic architecture as a data engineer, because this is the core skill set and we'll be learning about that, right? So I published this particular newsletter. If you are interested you can also subscribe to this. Just go to the datavidya.substack.com and you can subscribe to my newsletter if you want to get the high quality data engineering blogs. Okay, so data architect 101 for data engineers. Now till now we have understood that the goal of every data project is to solve a business problem. Okay, from the start of the video I've been saying this particular thing again and again, that everything you do as a data engineer or as an engineer only, right, you are doing all of these things for the businesses. Now it can be anything from reducing the current system cost to building the full-fledged data system to help businesses to make the data-driven decisions. Now I want to take you on a journey to understand how to think about building a data architecture from the data engineering point of view, because as you grow in your career you should have the basic understanding of how to design the architecture and how to build the data system. What is data architecture? Okay, so from the definition of the fundamentals of data engineering, a data architecture is a design of system to support evolving data needs of an enterprise. Okay, evolving data needs achieved by flexible and reversible decision reached through a careful evaluation of trade-off. We'll understand this technical architecture, but in simple terms, it is basically before you construct a building, right? You have to build a blueprint of a building, right? If you are trying to build, like say, 12 floor building, you have to first build the blueprint, and inside the blueprint you have to like add some of the things such as foundation, floor plans, elevation, elevators, stairs, office, restroom. All of these things you have to first plan it, and then you can start building the entire construction thing. Okay, so data architecture has a similar concept. Okay, instead of foundation, floor plans, elevation, elevators, you'll have to think about storage. What are the different software that you have to use? How does the data actually flows? Interfaces, how do you write the transformation? The staging areas, data warehouses, reporting system, and many more. Okay, so just like you think about building entire building, the construction, you also have to think about the data. When you are building a data architecture, you also have to think about what are the different components that we need in order to build the entire system. Okay, this is how we start. Now, as per the technical definition that we just read, okay, it says that decision should be flexible and the reversible, which means like each and every component that you put inside the architecture, in case something goes wrong, you should be easily replace it with something else, and it should be easily reversible. So every decision that you take, okay, and if goes into the wrong direction, it should be easily reversible, okay, so that you can make it right. So this is what it means, okay. It is achieved by flexible and reversible decisions reached through a careful evaluation of trade-offs. Okay, trade-offs are basically you have to understand based on your requirement which technologies that you can choose. We'll understand all of this step by step. Now, building a data architecture is divided into two different parts. One is business needs, and second is the technological integration. Basically, the operational architecture and the technical architecture. Okay, let's try to understand both of these right now, and then we'll deep dive into them individually. So we focus on the business goals and the requirement inside the operational architecture. Again, we understood, right? Everything that we are doing is for the business only. So before you think about right choosing the right technologies or the writing code and all of the other things, first you need to define what does the business even need on the first place, because once you know that, then you can think about the technological side. Okay, so that the first step into building a data architecture, or even if you're building your own personal project, you need to understand the operational side or the business side. So for example, in e-commerce platform, what is the impact of XYZ category of the product? So I want to find this particular thing. Okay, this is my business goal. I want to find the information about this particular product. Why is there a delay in product shipping? So I want to understand what is happening with the product shipping. Okay, so I want to understand what is happening with the product shipping, why there is a delay in the shipping, right? So this is my business goal. How do we manage the data quality from the third party vendors? So in the e-commerce, right, we are working with the different third parties such as FedEx or some shipping department, or the data might be coming from the multiple places. How do we manage the data quality while working with these vendors? Okay, so these are the different business goals that we have. So we need to think, while we are building a technical architecture, we need to think in this particular direction, that this is these are the different things that business needs. Okay, so now I have to build my technical architecture to fulfill all of these different requirements. So in the technical architecture, we focus on the technical side for solving how to ingest, store and transform data. What happens when we have the sudden order spike? Okay, so basically on the technical side, we all mainly focus on the storage technical things such as how do we ingest data, how do we transform data, and if there is a festival or there is a sudden spike onto the system, so we also think about the scalability. This is more of a system design side, right? One is a business goal, okay, where you focus on the business. One is the business side where you focus on what business needs, and second is the technical side. It basically you think about what are the different technologies that you can use. Okay, let's try to understand all of these things in little bit detail, okay, with the examples. So the operational architecture ensures that your data practice aligns closely with the business objectives. It is the why behind every piece of data you collect, process, and store. Again, business architecture or the operational architecture is basically the why. Why you are doing all of this entire activity? Why are we even building everything? Okay, it is to support business to achieve their goals. Okay, so operational architecture is basically the why behind every data that you collect. So here are the some of the insights to think about building the operational architecture, or defining the business goals. Okay, first is the start with the end in mind. Always begin by understanding the business problem you are trying to solve. This clarity will guide your decisions and ensure that your data architecture directly contributes to the business outcome. This is very important. Start with the end in mind. Basically, we need to understand what are the business goals before you even think about building an architecture or the technologies. Understand what the business needs, because once you define that, you can easily build the technological side. Technology is very easy to build if you know what business need. If you don't know what business needs, you will be stuck into building the architecture and you will never be able to get out of it. Okay, second is iterate and evolve. Again, business keeps changing every 6 months. New product line comes up, something keeps changing, business pivot. Okay, all of these things happens on the business side. So when you design your architecture, it should be able to iterate and evolve quickly as per the business changes. And the focus on impact, again, this is what we have been talking till now. Every single thing that you do, it should be able to generate value for the businesses. So every data solution you architect should have a clear line of sight to its business impact. Okay, it can be improving the customer satisfaction, streamlining operation, enhancing the decision making. The value of your data initiative should be measurable and aligned with the business priorities. This is operational architecture and aligning with the business goals. Now let's talk about the technical architecture. Okay, building block. This is where the actual execution happens. Why? Where, like, this is where the operational architecture is about why, the technical architecture is the how of the equation. By focusing on the specific technologies and methodologies, you will be able to meet your operational goals. So what we do, we use technologies. Okay, technologies is our how to meet the business goals, which is basically what that we want to achieve. Okay, pretty simple to understand. Now if you want to build the technologies, we have like thousands of tools available in the market, right? This is a big data landscape. Okay, and you can see there are so many different tools available. You can't even see until you zoom it. Okay, if you want to understand each and every tool, and these are the different tools available for different kind of workload. So over here we have a proper framework in order to choose the different technologies as per your business use case. Now you can't choose any random technologies and think about, okay, I'll use Snowflake, I'll use Apache Spark, I'll use the fancy tools just to solve my business problem. It doesn't matter. You can even use a simple Python script as long as it is solving and helping you to reach your business goals. Okay, technology is not about choosing the fancy tools or choosing something that everyone is using in the market. As a business, you should be thinking to save a cost. You should be thinking to reach your business needs. So whatever technology that helps you, it can be enterprise level technology, it can be the open source technology, whatever it is. Okay, as long as it solves your business problem, you are good. Now let's try to understand that one by one. Okay, how do you build the technical architecture? The simplicity is the aim is to keep your technical architecture as simple as possible while meeting your needs. This approach makes your system more maintainable, scalable, and less prone to error. Okay, the more simple things you keep, it is more easier for you to maintain it easy to scale, and it will be less prone to error because you will be able to identify the errors quickly. The more complex system you build, it will be much more difficult for you to debug the errors. Second is the choose the right tools for the job. Okay, there is no one size fit all solution in the data architecture. The right storage, processing, analysis tools totally depends on your requirement and the specific use case. Okay, so if you want the structured data, you can directly go with the data warehouse. Now in your case, if you have, let's say, millions of rows, you might not really need like Snowflake database or the Redshift database. You can also work with like basic ad hoc query interface like Amazon Athena, right? It will be good to go. So all of these different decisions you should be able to take as per your business understanding. Okay, it's not about choosing the fancy tools, it's about solving your business problem. Okay, I'll keep saying this. Second is third is the build. Third is third is built for the scale and flexibility. Now even if you are not dealing with the billions of rows right now, in future your business will grow, and if you are projecting that particular thing, then you should be planning the architecture for scaling all of these system, right? Currently you're using Python to process your millions of rows, but tomorrow you will know that you will have the billions of rows. So you should keep in mind that you should keep the system ready, okay, in the backend, that okay, tomorrow we are going to have the billions of rows, so let's start using the technologies that can help us to solve this particular problem. So you can go with the distributed processing, such as use Apache Spark, okay, and then scale up the cluster. So you can start with a smaller cluster and then think about scaling all of these different clusters. So all of these things you evolve as you move forward. It's not that everything is perfect when you get started. You start small and you start evolving as you move forward. Okay, third is the embrace automation. So a lot of time you might monitor a different system manually, might try to solve the different errors manually, you build the data pipeline manually. So instead of that, you should generate script, generate automation to do all of these different things. So in case some error occurs, you should directly get the email or the Slack notification, okay, as per the your system integration. So instead of you going to check every single day, okay, if my data pipeline is working or not, you should have an alerting mechanism already in place so that you don't have to go and check that. Then prioritize the data security and the governance. Basically in digital age, the data leakage is quite common, so you should properly secure your database. You should encrypt your data. You should keep your data secure within the network. So these are the different things you need to take into the consideration while building your technical architecture. Okay. Now let's try to bring all of these different things together just to understand how this happens in the real world. So let's take the example of the data architecture for the e-commerce platform. Pretty easy to understand. First thing that we understood, that we need to understand what does the business need. Now in this case, let's define the business goals. Okay, because this is what we understood. First we define the operational architecture, like what are the goals of the business. So in this case, goals, the first goal is the customer experience, improve site navigation, personalized product recommendation, and customer service. Simple to understand. We want to improve the overall site navigation, how customer interact with the application. Recommendation, we also want to build the recommendation engine, and customer service interaction. Okay, we also want to integrate that. This is the customer experience. Then operation efficiency, so streamline the inventory management, order processing, and shipping to reduce the cost and delivery times. Okay, we need to uh, improve our entire operational efficiency, so we can reduce the order processing time, we can reduce the shipping cost and also the delivery times. Then marketing insights, we also want to understand how customers are behaving, so that we can improve the product placement and increase the sale. Vendor management, so we might be working with a different vendors, so we also want to build a strategy for the better product availability, pricing strategies, and the quality control. And fifth is compliance and the security. So a lot of time in e-commerce platform, people will be making payments. Okay, there are some compliance that we need to follow. That let's say we don't capture the credit card information. Even if we capture the credit card information, we should mask all of this data so that it doesn't get leaked. So these are some of the compliance that you have to follow in order to achieve them. So these are the business goals, right? We understood we want to increase the customer experience, operational efficiency, marketing insight, vendor management, compliance, and security. We understand the business goals. Now, as per these business goals, we can think about building the architecture, the actual technical architecture, right? So first is our data ingestion layer, right? Because we are getting data from multiple sources that we understood. So how do we ingest all of this data? So the purpose of the ingestion is to collect data from the various sources such as website interactions, server logs, vendor system, inventory management, customer support. So we are getting data from multiple places. So we can use a technology in this case, like we can think about, right? If I have like data coming from all of these different places, which technologies can help me to do this? Okay, and if you just Google and if you ask few experts, you will know that okay, the technology to handle all of these things is Apache Kafka. So you can just put the Apache Kafka as a real-time data streaming, so all of these data will go there, and you can easily capture it. Once we capture our data, we need to store all of this data to some object storage for the longer period of time. The purpose is to store collected data in structured manner for easy access and analysis. Now, different components, if you just want to store the unstructured data, you can go with the object storage like S3 bucket. Okay, and if you want to structure your data, you can go for the data warehouse. Like you can use Snowflake, you can use BigQuery as per your business requirement. You can go with that. Now, how do you decide like which thing to use? Like, should I go with the Snowflake? Should I go with the Redshift? Again, it totally depends, right? If you're already on AWS, okay, going with the Redshift might be the good choice because of the integration. But Redshift, let's say Redshift is expensive for your business need, then you can go with the Snowflake, or you can also go with the open source. All it is, like, you have to research about it, you have to understand your data size, you have to understand uh, your data frequency, you have to calculate all of these different things and just do simple POC, right, proof of concept, to understand how different technologies are behaving for your data, and whatever works best you can choose that. So that is the thing that we talked about, right? Every decision should be flexible and reversible, so in case something goes wrong, you should be able to replace that particular thing quickly. Okay, so let's say if we go with the data warehouse, okay, so we might have to structure our data before we put our data into the data warehouse. That is where the data processing and transformation layer will come into the picture. So this is where we will clean, validate, and transform our raw data into the structure format. For this, we can use Apache Spark if you are working with a large data set. If you already have like a small data set, like few millions of rows, you can go with the simple Python script. If you think that you have a large data set and data is coming from the multiple sources, you go with the Apache Spark. This is one of the like highly used framework used by the top companies. Okay, all of these decisions you can just Google it and you will find a lot of plenty of resources. Now, after we put our data onto the data warehouse, this is where the data analysis and business layer comes into the picture, where the machine learning engineers and the data analyst comes, builds the dashboard, builds the machine learning models for the predictions to help business to move forward. This is where the final value comes, right? I build a dashboard, a person from the business team can look at the dashboard, they can see, okay, we are having this issue in the shipping, we can take the right decisions, use the data, okay, and improve the overall business. So this is where the business intelligence tools like Tableau, Power BI help us to visualize data, and machine learning platforms like TensorFlow and PyTorch to help us to build the recommendation engine and build the algorithms. There's also the side of data security and compliance, where we can ensure that we meet the regulatory compliance such as GDPR and CCPA. Just Google it, you will understand these are the government compliance that you have to meet when you store your data into the system. So government will tell you that, okay, you can't store the personal information of users, you can't store the credit card information. So what we have to do, we have to either encrypt all of this information or we have to mask all of this information. We have a small session in this video about the masking, so you will understand that particular thing over there, so don't worry about it. Okay, and then, okay, wait. And then the last thing, we have the data integration and API layer. So again, we will be working with the multiple vendors. We will be sending data between different systems. So we should build an API so that we can easily have an integration between different systems. Okay. So we also have to think about this. So if we meet all of these standards, our final architecture might look like this. Okay. This is not the final architecture, but it might look like this, and you can improve on top of this. So as you can understand, we have a data coming from on-premise social media and stream data. Okay, now this data is getting ingested onto the system. We are using the AWS cloud. This is getting stored onto the AWS S3 as a data lake. So all of the data that we are storing, it is getting stored inside that. Now we can use a transformation layer such as AWS Glue and Lambda to process our data, and then all of these things we can put it onto the Amazon Redshift. Either we can also use Amazon Athena, which is the ad hoc query interface, and SageMaker as a machine learning platform. Okay, and then we do visualization. So this is the architecture that we build to fulfill our business needs. Right, we define the business goals. Then, as per the business goals, we define the different tools that we can use, and then we build the architecture. Now, if you see this architecture, this looks something similar to the data engineering lifecycle that we saw. Okay, there is a data collection, the ingestion is happening over here. Okay, we have a data storage, we have a data transformation layer, we have a serving layer, and we have the end users, right? The people who use the application. The data engineering lifecycle that we understood is the fundamental block. Okay, this is the real world architecture where you apply the concept of data engineering lifecycle to build the entire architecture. Over here you can plug and play. So instead of using S3 as a data lake, you can use Google Cloud Storage if you want to use that. Instead of using Amazon Redshift, you can replace this with the Snowflake database. Instead of using AWS Glue, you can use the Databricks, right? Instead of using the data lake as a streaming, you can use the Kafka. It is as per your requirement what you have to use to fulfill your business need. Okay, this is everything about the building architecture. I hope you understood. If this is clear, okay, we can move forward and go and understand about the other parts. Okay, let me check this. All right, this looks good. Let's continue with our second thing. Okay, so now that we understood about the architecture and how does the architecture is built, let's try to understand the individual components of the architecture. What is the use case of it? How does the entire execution happens, okay, while building this? So let's start with by understanding the data warehouse. Okay, this is what the architecture of data warehouse looks like. Let me just remove this. All right, so this is what the architecture of data warehouse really looks like. Again, we know this. We have a data coming from the multiple places. We have already discussed data comes from APIs, data comes from RDBMS, data comes from website. All of these places are generating the data. Right, now this data goes to the streaming engine and gets ingested. We write the ETL pipeline. Okay, after the ETL, our data gets stored inside the data warehouse. Okay, this is the ETL pipeline. Okay, what we are doing is that we are extracting data, we are doing some transformation, and then we are loading our data onto the data warehouse. Okay, and then we have a data mart. We will understand about the data mart. We have a dedicated slide for that, but this is the simple understanding of data warehouse. Now I want to deep dive into the individual components of data warehouse and how does the data warehouse is built. We will talk about dimensional modeling, okay, and we will talk about the slowly changing dimension. These are the two concepts that I want to touch that is important for building a data warehouse. Okay, so let's talk about that one by one. Let me see if you guys can see this properly or not. Yeah, it is fine. Okay, I think this is proper. Yeah, this is fine. Okay, this is fine. Wait, so this is the data warehouse. So this is what we call as a ETL, right? Where we extract the data, we transform the system, where we extract the data from the data source, we do the transformation, and then we load our data to the data warehouse. There is one more concept called as a ELT, where instead of where instead of transforming our data, we first extract, okay, then we load our data to the staging area. We can directly load our data to the data warehouse, okay, we can directly load the data and then do the transformation on the fly as by using the SQL queries. This is the ELT. Okay, simple. We extract, transform, load, ETL. We extract, first load it, and then transform it as per our requirement. Okay, these are the two things that you can use to build a data warehouse. Usually in the real world, people only use ETL. Okay, ETL is highly used because this is the most structured way to organize your data. ELT is also used. A lot of new companies are trying to replace the ETL with directly ELT, where you don't have to do the transformation layer. You directly load your data to the data warehouse as it is, and then do the transformation as per your requirement. But again, it is not that successful because a lot of data are quite messy in the real world. You have to do some processing before in order for you to at least store your data into the data warehouse because data are quite messy. So ETL is what you will be using most of the time, but it is good to have the understanding that ELT also exists for some use cases. If you have a properly organized data, you can directly load it onto the data warehouse and uh, do the visualization and all of the other things. Okay, now we understood in our relational database part, we were building a data model, right? We understood about the data model. Okay, what is data model? Data model is basically the visual representation of how our data looks onto the relational database. Now data model are normalized, so what we try to do is we try to create as many as tables as possible and reduce the duplicates inside each and every table. Okay, so that we have a proper information stored across different tables. Let me just show you that again so that you have the clarity about the data model. Okay, this is what it looks like. Again, a very bad way to represent this, but if you remember, we had like different tables that stores different information, and if we want to get the information about, let's say, a particular user who purchased a particular product, okay, what we have to do, we have to pull the user ID, we will have to connect with the order to get the order information, and then we will have to connect with the product information. If you want to also track the payment information, we will have to connect the payment ID. We will have to join four different tables to get the one outcome. That is one thing. Okay, second thing that we also understood that, okay, we can get that by joining, but data relational databases are not designed for this kind of workload. Okay, because what happened, so we understood that the relational databases are not really designed for analytical workload. So even if you join all of these data, if you try to run some analysis query by aggregating the user information or aggregating the order information, this OLTP database, okay, OLTP database will go down because it is not designed for this kind of workload. What it will do, it will pull all of these different rows one by one, okay, and then it will pull one single column for your final analysis. Not good. Okay, this is where we have the data warehouse, but we can't directly store our data into data warehouse just like that. There are specific methods to store our data, and that is called as a dimensional modeling, right? Just like we have a method to store our data into the relational databases that are called as a data model, we have a method to store our data into the data warehouse called as a dimensional modeling. Okay, now in the dimensional modeling we have two things. One is called as the dimensions. Okay. Second is called as a facts. Okay. These are the dimension and these are the facts. What is the meaning of this? These are the two types of tables that you will create to build your data warehouse. This is called as a dimension tables. Okay. This is called as a fact table. Now, fact table is always one. Okay. So you will have uh, one fact table. Okay. And multiple dimension table. Now, okay, I have the one fact table and I have the multiple dimension table. Fact table will store the information about the quantitative data points, such as something that you can measure in the business. It can be such as sales amount, quantity of the product that got sold, revenue, profit. All of these are the quantitative value that gets stored inside the fact table. Okay, all of the information about the business that you can measure, the fact table stores all of the quantitative attributes, and it is the center of your dimension modeling. Okay, we will understand about that. And second is the multiple dimension tables. These are the different dimension tables as per the business category. So you will have like a product dimension, you will have the date dimension, you will have the order dimension. Each and every dimension table will store the information about the categories or the descriptive attributes, such as product name, product category, uh, uh, username, user age, user city. Okay, all of these are the descriptive attributes about the particular dimensions that get stored inside the dimension table. Now again, if you want to understand about how all of these things happens in detail, I have a course available onto the data warehouse with the Snowflake database. If you want to understand, I go deep into it. Okay, I'm just trying to give you the overview as a fundamental right now. Okay, now how does the dimensional modeling actually build? Okay, we have a two concept for that, called as the snowflake schema, okay, and star schema. Okay, these are the two methodologies, or you can say concept, to build the dimension model. I just want to show you this. Okay, it looks something like this, as you can see it over here. This is my star schema and this is my snowflake schema. As you can see, in the star schema, we have one fact table available in the center, and there are different dimension tables that are attached to it. Simple, it looks like a star. That is the reason the name is given star schema, because there is a fact table in between and there is a dimension tables that are attached to it. And then the snowflake schema is basically, if you look at the center, it is a star schema, but there are sub dimension tables attached to the dimension table. So it is just a little bit normalized version of the star schema. Okay, kind of looks like the relational data model, but there is a fact table and there are different dimension tables you can create as per your requirement. Okay, so we understood, in the star schema you will have the fact table in between, and there are different dimension tables that are attached to it. Okay, that can be joined over here, and this will create the star schema. Snowflake schema is the same as the star schema. Okay, but you will have the sub dimension tables created for it. Over here, there's my dimension table and these are my sub dimension tables that you can create for each and every dimension. Okay, this is my snowflake schema. Now the snowflake is different from the snowflake database. Okay, this is a concept of the data warehouse, and snowflake is a company, okay, that gives you database as a service. Okay, now how does this happen? Let's take look just look at the example. Let's say we are again working with the e-commerce company. Okay, and we will have the fact table in between. Okay, this is my let's say order fact. Okay, this is where it stores all of the information. This will have the unique ID, and this will have all of the quantitative attributes, such as let's say price. Okay, let me just reduce this quantity. Okay, it is what else we have, like weight. Okay, all of these are the quantitative attributes that you can measure by aggregating it. And then we will have the different dimension tables. Okay, I will have the order dimension, I will have the product dimension. Okay, I will have, let's say, date dimension, like this. like this, there are different dimensions available, such as the we can create the dimension for the third party vendors, you can create the dimension for the shipping, all of these different dimension, and every dimension will store id, okay, the primary key, and such as product name, okay, product category, or product these are all of the descriptive value, right? And then once you have the information stored inside the product dimension, what you can do, you can create the foreign key, such as this is product id, okay, and then using the id you can join this. Just the same thing you can do it for the order, the same thing you can do it for a date table and everything else, okay. Basically you create the fact table, in between you store all of the transactional values information, you create the dimension tables differently, and you join them with this common key so that you can do the final analysis. This makes the analysis easier, because if I want to get the information about the product and get the quantity of the product, I just have to join the two tables, okay, that is also stored onto the data warehouse. So after the join, it will only pull the single column for the analysis, okay, that we understood about the OLAP. Again, if you want to understand about all of this, I go with the hands-on in depth in my data warehouse course. So if you are interested, do check the course details into the description, okay. Now we understood about this, right? Fact and dimension. Now I want to understand about the slowly changing dimension, that we understood, right? These facts such as quantity, product weight, price, all of these things keeps changing, right? Quantity keeps changing, product price keeps changing, so we can easily update it from the system. We understood, right, how the data is flowing over here. I'll keep reminding this to you. Okay, data is coming from sources. These are the different sources, such as API, web, RDBMS. These systems are generating different values, right? Let's say someone purchases one particular product. Right now we have the total quantity of the product, as this is my quantity of the product, right? Someone purchases that product, the value of this product, the quantity will be 5, because the one product is already bought, okay. We need to update this information over here also in future, okay. So this particular thing will get updated as the data flows from the multiple sources. It goes to the ETL, okay, it goes to the data warehouse after that, okay, and it gets updated using the updated query or the merged query, whatever it is, okay. It gets updated on a daily basis, hourly basis, whatever it is, okay. This is how the system is flowing. But these dimensions, right, we understand these dimensions don't change, okay. The product name does not change. User, let there is a user table, user address do not change every day, right? User city do not change. uh, all of these things are the dimension values do not change for the longer period of time. But when they do change, right, how do we update that? How do we tackle that information? Because these things we can easily update it, right? But the dimension values changes very slowly. That is a concept called in the data warehouse called as a slowly changing dimensions, okay. One of the important concept that I just wanted to include over here, because again, dimensions are changing one by one. How do we handle the dimensions? There are some strategies available, okay. Let's say if I move my city, I'm currently living at, let's say, Mumbai, and tomorrow I go to Delhi. uh, this needs to get reflected. This will automatically get reflected onto the source system, right? RDBMS or anything. But this also needs to get updated onto the data warehouse also. And we need to build a system, right, that tackles this particular problem. And this is a concept available, slowly changing dimension, that we will look, okay. And slowly changing dimension, we have like multiple different approaches, and it is divided by the different numbers: SCD1, SCD2, SCD3, and each and every approach has their own way of handling these slowly changing dimension values, okay. Let's look at the first one. In SCD type 1, okay, the values are overwritten and no history is maintained. So if you go with this particular type, it basically means whenever you overwrite your data as it is, you are using the SCD1, okay. This is just a concept. So once the data is updated, there is no way to find what was the previous value was. So as you can see, the customer ID is 1, the name is Adam, and currently he is living at the New York City, and there's an email and all of the other columns. After this, if we use the SCD1, all right, as you can see, we will directly replace New York with the New Jersey updated over here. In this case, the city column is changing from the New York to New Jersey, and the value is just getting overwritten. So in case if we want to find what was the previous city of this user was, we won't be able to do that because we are just overwriting this. You can use this for some use cases, but then let's look at the SCD2. Okay, in SCD2 we have like multiple series starting. Wait, stop. Okay, so in SCD2 we have multiple approaches. We maintain the complete history of changes. Every time there is a change, what we do, we add a new row with all of the details without deleting the previous value. Over here, what we will do, we will add a new row, okay, without deleting the previous value. And there are multiple ways we can tackle this, right? We can either use the flag approach. So over here, what we will do currently, let's say the city is New York, okay. After the city, first the city was New York. So it is, we will add a new column as is active, okay. And as you can see, it is currently true. That means this particular user is currently living in the New York, okay. There are some updates happens, okay. First he was living at the New York, then New Jersey, and now currently he is living at the Miami. So as you can see, the is active is false, false, and true. That basically means this is the most recent version where the user is currently living, and these are the history where he used to live, okay. So using this, we retain the information about the past. This is what we can use the flags. There is one more approach. We can also use the version number, so we can keep track of 0, 1, 2, and we can directly get the max version to get the latest value of the active value, okay, where the current user is living, okay. We can use the version information. First we can use the flag, second is we can use the version, and third we can also use the date, okay. We can add a start date and end date information. So as you can see, he's living at New York, okay. That is the reason we have the start date, but for now we don't have the end date because he is currently living at that particular location. So wherever the end date is null, that means the user is currently living there, okay. So as you can see, first New York, start date was like 1st January 2020, and 20 end date is like 25th March 2020. Now he went to New Jersey, start date was 25 March and till 1st December. So he lived in the New York for 3 months approx. In the New Jersey, he lived for like how many? Right, 9 months. And now currently he is living at the Miami because the end date is null, and this is the my current active column. So these are the three ways you can design SCD2. Okay, if you want to keep the previous history. There is also SCD3. Okay, where you only maintain the partial history, right? Over here we were maintaining all of the histories, but in SCD3 you maintain the partial history. That basically means, let's say we have a city. If we want to also maintain the partial history, we will just add a previous city. So in case there's a New York, currently the previous city is null, okay. Then there is a city update. Currently he's living at the New Jersey and the previous city is New York. Let's say there's one more update for the city. He moved to, let's say, Mumbai, okay. So there will be Mumbai and the previous city will be New Jersey, okay. This will be my previous city and this will be my new city, and customer ID will be customer ID will be one, and the name will be Adam, because we are directly overwriting onto the current and the previous one, okay. So this is how you design the SCD3, where you just maintain the partial information. You can also think about STD4 and 5, but that is not that relevant. Let's think about the STD6. Okay, this is basically a combination of 1, 2, 3, where you capture the current city, previous city, start date, end date, and also add a flag to keep the track of the active thing. So the combination of 1, 2, 3 SCD is basically this. Now again, this is just a fundamental concept. If you want to do the hands-on practice, just Google it. You might find some tutorials. If you're interested, just check my course. I go in depth and I teach you all of this concept onto the Snowflake database. So you also learn the foundation, but also do the hands-on on Snowflake database, okay, on the real data set. So this was the concept of SCD on the data warehouse. There is one more concept that you should understand, that is called as the data marts. Now again, let me drink water. Yes, you can also drink water. Okay, so data marts. Now data marts are basically a subset of data warehouse. Okay, To understand this, the subset part, we understand, right? In data warehouse, we have many different tables available like this. Okay. Now these tables can be, let's say, product information, order information, payment information. Uh, we have the fact table, like the fact table information. Okay. These are the product dimension, order dimension, payment dimension, user dimension, date dimension. Okay. These are the different tables available in data warehouse. Now, like this, there are many different teams working in the organization. Okay, we have the different teams available, such as the teams might be about shipping. Okay, who handles the shipping information. There's a team who handles the refund information. Okay, there's a team who handles the payment. There's a team who handles the third party. Okay, accounting, IT. These are the different departments available inside the. These are departments inside that we have a different teams available. Now, all of these teams don't really need this entire data set. Okay, every team wants to solve their own business use case. So understand this. This is my company. Okay, this is my company. Inside company, okay, I have different departments. Okay, these are my departments. Okay, inside the departments, we have different teams working on different problems. Okay, if you work in any company, you will see that. If in the large company, you will see always like this something. Okay, you will see something like this, where we have the company. Inside the companies, we have the different departments. Inside the departments, we have different teams trying to solve their own department's issue so that they can meet the company goal. Okay, it looks like something like this. If this team solves their own problem, that basically means they are solving the department problem. That basically means they are solving the company problem. Okay, and if all of these different departments solves their own problem, that basically company is moving forward. Now, in order for these departments to solve their own problem, what they want to do is that they want to build their own reporting system, right? The analysis, data science, machine learning models, what they do is that they build the reporting system as per their team's requirement or their department's requirement. And what they do is that they create the subset of these data warehouse as per the requirement. So instead of, let's say, for a shipping department, right? They just need the information about, let's say that for example, they just need the information about users. Okay, uh, let's say payment and the product. Just think about that. Okay, they just need the information about these three uh, information from these three tables only. So they will create their own new table. Okay, using these three tables, and they will choose the columns that they need for the reporting and all of the other things. Let's say there are 300 columns available in these three tables. They will just pick, let's say, 100 columns from these three tables. Okay, and they will build their own reporting system for their own department. This is called as a data mart, right? I am building the This is the subset of a data warehouse. I'm building my own reporting system. I'm building my own table as per my requirement. Data mart, a subset of data warehouse. It's pretty simple to understand. I solve my department problem, that helps the company to solve their own problem. Simple. Okay. Uh, Understood the data mart concept? Let's move forward. Now the data lake, right? This was the new term that was tossed because of the object storage. Now, okay, before we store our data into the data warehouse, we understood, right? What we have to do, we have to, again, data comes, it goes through ETL. Okay, and then you can build a data warehouse and store your data. Every data that you store inside the data warehouse, it gets stored inside the structured format, right? It is getting stored as a structured format. So what that means is that every time you want to store your data, or every time you have to make any changes, you have to uh, make changes in the structure, and that is quite difficult to do that, right? If you have a table that has already millions of rows of the data and has the 5 column. Okay, think about this. I have a table. Okay, 1 2 3 4 5. Okay, 1 2 3 4 5. It has 5 columns and it has like millions of rows. Now in the data warehouse. Now tomorrow I decided to add one more column. Okay, inside the data. So all of this value will be null. Okay, I will have to change the entire structure, and then I will start adding the new rows as per the new data. So changing of the structure, changing of the schema type is quite difficult in data warehouse because you have to take a lot of things into the consideration. Now data lake comes, what it says, right? Okay, you don't worry about the ETL. Okay, You don't worry about the ETL, you don't worry about the writing transformation and putting your structured data. What you can do, you can use a data lake as an S3. You store all of your data into the data lake. Data lake is basically a storage location. You can use S3 as a data lake storage. Okay, it is a centralized repository where you dump all of your data as it is. Right, I will store all of my CSV data. I will store all of my Parquet data. I will store all of my JSON data as it is onto the different folder structure onto my data lake. Now, different teams from different departments, we understood, right? As a data mart, there are different teams working over here. There are different teams working. They want their own columns, they want their own tables, they want to generate their own reporting. So what does the data lake says, that you dump all of your data as it is onto the data lake. Okay, as per your requirement. Okay, you can query the data from the data lake itself. Basically, you can directly read the data from S3 file storage system, okay, object storage system, as per your requirement. This is called as a schema on read. Again, concepts are getting quite heavy, but I'm just trying to keep it easy. So take a break if you want, but I'll keep continue. Just pause the video if it is getting heavy and come back again. Or but if you can understand, just go forward with it. Okay, it is basically the centralized repository. Okay, uh so data lake is basically a centralized repository. You can use S3. Okay, you can use Azure Blob Storage or Azure Data Lake. Okay, Azure. You can also use the Google Cloud Storage. Okay, as a data lake, which is kind of like the object storage, where you dump all of your data as it is, as a raw. Okay, and on the other side, on the data lake, there are users or the team. Okay, who can read this data. Okay, this is called as a schema on read. Okay, what they will say, okay, I want to read this column from this file, I want to read these columns from this file, all of the different file system. Okay, I will read all of this data as per my requirement. Okay, and I will build the table onto the, let's say, Athena. Okay, Athena or any ad hoc query interface. Okay, that is up to me, and they will build their own table, or they can directly also put the data from data lake to data warehouse and put it into the structure format. So here we will only process the data that we need. Okay, instead of processing all of the data over here in the ETL and data warehouse part, we will only process the data that we need, and then we store that data onto the data warehouse for the querying purpose. Now, it is not that, okay, data warehouse is bad because it requires a lot of processing, or the data lake is good. Both of the system has their own place into the architecture, because data warehouse gives you the flexibility of the structured data, so you can do the analysis, where data lake gives you the ability to access any data anytime you want as per your requirement. Okay, let's understand the difference between data lake and data warehouse. Okay, inside the data warehouse, data is structured as you can see it over here. Let me just okay, let me just zoom this. Okay, data is structured. Okay, the users are business analysts, and it is used by the batch processing for the BI reporting and all of the other things. The data are redefined, contain smaller data, and it is usually the relational, right, column in the uh, row format. Over here, data are unstructured because you can store JSON data, you can store Parquet, CSV, whatever you want. All right. The users are usually data analysts and data scientists, because instead of like, think about this, right? Data scientists want to build their own machine learning models. Now, in the data warehouse, all right, once you have a data added, you can only work with the limited data, right? Because you define that as per the business goals, and the changing of this structure is quite difficult. You have to do a lot of changes inside the pipeline also. So for data scientists and data analysis, data lake is a gold mine, because it is completely raw data, right? It is stored as a file storage. It is stored as a file inside the object storage as it is. It is up to me which data that I want to read, what are the columns that I want to read as per my requirement. I can read using the Python code, I can write the Spark code, I can build a table on top of it as per my requirement. Okay, so these are the users. Use case is for the stream processing, machine learning, real-time data analysis. You can use that. Okay, the data is raw, data are large, and it is undefined. Okay, it is not properly relational, so it is undefined. Okay, this is the difference between data lake and data warehouse. Okay, this is what we understood till now. Now this is just a fundamental concept, the actual hands-on part. If you want, I have some projects available freely on the YouTube channel. Okay, I will just comment down, I will give you the link about that. Okay, so if you want to do that, you can do it and understand about the data warehouse and also data lake. I also teach all of these things hands-on on my courses. So if you are interested, just check the link in the description about the combo pack. Okay. So till now we understood about a lot of different things. Okay, we started by understanding what is data engineering. We understood what data engineering is. Where does the data engineering actually fits into the entire pipeline? Okay. We understood about like the different roles such as software engineering, DBA, DE, DS, ML, all of the other things. We understood about the important part, which is the data engineering lifecycle. Okay, we understood about the generation, ingestion, transformation, serving, how all of these things happen, storage part. We understood about how, why the transformation is needed, like how does the transformation actually happens, data generation, data storage, DBMS systems, the relational databases, data modeling. Okay, how does the data modeling actually happens? NoSQL databases, SQL versus NoSQL, data storage processing such as OLTP versus OLAP, uh, difference between row-based transaction and the column-based databases, why OLTP is needed, why OLAP is needed, why does the transformation is needed, because we go from OLTP to OLAP while doing the transformation. Okay, understood about the ETL processing, understood about the undercurrents such as security, data management, data ops, architecture, orchestration, software engineering. Dwell deep into the data architecture part. Okay, we understood about the operational architecture and the technical architecture, understood about a lot of things, understood about the data warehouse, important part. Okay, ETL versus ELT, understood about the dimensional modeling, understood about the snowflake schema and the star schema, understood about the difference between fact table or dimension tables, such as how to build the dimension tables, it stored the transactional values and the categorical values. uh, Understood about the slowly changing dimensions, why do we need it, different types of it, a lot of things. Data marts, subset of the data warehouse, why do we need the data marts, understood about the data lake and the difference between data warehouse and the data lake. Okay, understood a lot of things about data engineering actually. I was not even expecting I'll go into this deep. Before recording this video, I thought like I'll just give the overview, but I went into the flow state and started recording and started explaining everything because I really love teaching, right? So understood a lot of things. If you reach till this section, do let me know first by commenting, because it might be around 2 hours till now, and if you're still watching, salute. All right, so do let me know by commenting that you watched this video till here and you are about to complete the entire thing. Okay, and I just want to plug my courses, that if you're interested, right, if you love my teaching and the way I teach, then do check out my data engineering courses. I create in-depth data engineering courses in the market. Okay, it's not just course, it's about giving you the experience, okay, understanding of proper technology, how does this work in the real world, right? It's not just about learning technologies, it's about understanding where it is used, how to use it, following the best practices. All of these things I teach on my courses, so do check them out. You'll find the link in the description. You will also find the latest coupon code available with the huge discount, so go at least check that out. And yeah, let's continue with our video. Okay, now we understood the fundamentals and we also looked at this big data landscape. Let me just zoom this, right? Can you see the tools name? Can you see like different things available, right? These are the data warehouses. Okay, as you can see, Snowflake, AWS, Redshift might be here, Microsoft, Firebolt, Oracle. There are some new companies here. This is used for data lakes. As you can see, there might be S3, Databricks is used, Dremio is used, Cloudera has their own stuff going on. This is storage system provided by the different NoSQL database like MongoDB. There might be Cassandra somewhere, CouchDB, and all of the other things. Real-time databases, graph databases. You see, I was telling you about this, right? For every single use case, like for visualization, BI platform, data science notebooks, ML ops, there might be some product analysis, all of these different things, right? We have a set of tools available, right? Every single technology, every single that we want to do, we have a different tool set available for every single, that we understood while we were talking about the architecture part. We understood that uh, every single thing need a set of tools, and we have like more than thousands of tools to pick from. Okay, now we will understand about these individual tools, what they do, why they exist, right? What are the use case of it, which tools are the mostly demanded and used by the industry. Okay, so that we will understand and how to work with them. Let's go one by one. Now let's talk about the cloud platforms, right? We understood about the cloud platform. uh, Cloud platforms are basically a giant computers built onto some data, the basement of a company. It can be Amazon. Okay, this is Amazon. This is Google. Okay, and this is Microsoft. Now again, these are the three top cloud providers available in the market. There are plenty of the cloud providers. You have the Cloudera, you have the IBM cloud, you have the Oracle cloud. Every different cloud providers has their own feature, but these are the three top cloud providers available. What is cloud computing? It is basically these companies give you the compute resources and the different services so that you can use for your work. Before this cloud, what we used to do, we used to build our own servers. Okay, own servers. That means you get your RAM, you get your hard disk. Okay, you get the processing power, processor. Okay, you get the GPU if needed. You get all of the wires, you get the ACs to cool down servers, you get the networking adapters, you get all of these different things, switches, you get the routers, every single thing. You get it, you build it by your own self. Okay, now you can do this. A lot of people still do it because they want to save the cloud costing, but this also comes with a trade-off because you have to maintain them. Okay, you have to maintain this. What if the power goes down, right? What if my one hard disk fails, and what if I lose all of my data? You also have to think about replication. You have to also think about the scalability. Okay, how do I scale this entire thing? Because let's say right now I'm just working with the millions of data and the users are small. Tomorrow my business grows, so I have to buy new hardware. Okay, and upgrade my system. What if the my hard disk fails? What if my RAM fails? Okay, hardware is that. What if the something comes, like earthquake comes, and I lose all of my data center resources? It can, anything can happen, right? You don't have the control over the nature. So this is the reason, okay, people usually go with the cloud providers, because I don't want to set up all of these things by myself. If I can directly pay to the cloud providers, okay, and these cloud providers always charge pay per use. Okay, pay per use. That only means that you only pay for what you use. That's pretty awesome, right? I will only pay for what are the different resources I use. So if I just use the simple virtual machine, which is like the online computer, and I run it for the 2 hours for my some workload, I am only going to pay for this 2 hours only. Okay, I will not, in the on-premise center, I will have to keep running these machines 24 hours, because this is how the entire server is set up, right? If I want to store, because I will be running some other workloads. My website is also hosted on that. There are some other functions that are going databases and everything. So I have to keep it running for 24 hours. Let's say if we just want to do some workload for quickly for 2 hours onto the cloud, I can also rent that, and I can also pay for that use case. And cloud has multiple services available for the different use cases. Okay. These different services I divided into the three different parts. We have PaaS, okay, we have SaaS, okay, and we have IS. Okay, this is platform as a service, this is software as a service, and this is infrastructure as a service. What these three things means, right? Platforms is that they give you the direct platform, so you don't have to worry about setting up different things. So for example, uh, uh, what? For example, on AWS we have a service called as the AWS Lambda. Okay, if you can call it as a platform as a service, because they directly give you a one kind of platform where you can just focus on writing your code. They will take care about all of this infrastructure side, such as running the server, all of the backend thing. They will take care of the maintenance and everything. You just focus on writing your code. This is called as a platform as a service. Second is a software as a service. You can think about software as a service as a Google suite. All right, you have the Google Sheets, app script, not the app script. What do we have? Like Google Slides. You have their entire Google suite. You can think about as a software as a service because they are directly giving you access to the software as a service for your work, so you can use that and grow your business. Then we have the infrastructure as a service. Okay, that basically means cloud providers will give you the infrastructure. So example of this is EC2 machine. This is basically the virtual machine online. There's one more EMR, which is like the elastic map reduce to run your Spark jobs. There are different infrastructure that they give you so that you can run your workloads. Okay, this is how cloud platforms are divided into three services. They give you these services that you can use to grow your business, right? Now, these services have different names as per the cloud providers, right? If I go to the AWS, right? On AWS, we have these many services and many more. These are the some few services, right? We have EC2. Just don't worry about the names. If you are seeing it for the first time, just forget like what it means, right? Don't worry about it. If you already know, that's good. But if you are seeing these services or these logo for the first time, just forget about it, right? There's some called EC2, which is like the virtual machine. We have the Lambda where you can just run your code onto the serverless machine. Okay, elastic container service if you want to run the Docker image. Okay, there is like simple email service. It is used for the notification purposes or the email purposes. Aurora is a database created by, so if you want to store your data, relational data, it is a service. It's like AWS is giving you the service, so you only pay as number of like hours you use or the number of resources that you consume, so that you don't have to build all of these things by yourself. Everything is built for you. Pay for it. Grow your business. Elastic Cache, DynamoDB, right? EMR, VPC, CloudFront, Elastic Load Balancing, Kinesis for real-time data, RDS for relational databases, Redshift for data warehouse, right? Kinesis, Elasticsearch for some IoT devices, simple storage service, object storage to build a data lake, right? File system, Elastic Block Storage, Cognito, API Gateway, Queue system. You think to build your entire technical architecture, right? We understood. We have the business goals, but once you define the business goals, you think about, right? Now I want to build my technical architecture. So you start thinking, okay, which cloud computing platform should I go with? Most of the time, you might have the answer. Let's say you are a student right now. Okay, you might have a question that, Darshil, which cloud computing is the best and that will give me the job? The answer is pick any one from the three, and there are high chances that you will get the job because most of the companies only work with these cloud providers. If I were to rank them, okay, this is just my personal opinion, it can be wrong. This was my opinion like few years back, like 1 year back, you can also say that. I used to rank AWS as one, okay, Azure as two, and Google Cloud as three. Okay, now it is quite changing, and I'm seeing the trend as Azure can be one because a lot of companies are using Azure due to their new functionality and the good services. The services that they provide are specific for the enterprise level. So Azure is good. If you want to target the enterprise level company, they always go with the Azure, especially in India, because a lot of companies directly use the Microsoft app suite like Microsoft 365 as the enterprise level because Microsoft Word, PowerPoint, and on all of the other things. So they are likely to go with the Azure because the integration is quite simple, right? A lot of startups usually go with the AWS because AWS gives you the good credits. You can easily start, and a lot of people know AWS. Like industry, if you want to find the resources or the employee for with the skills of AWS, it is quite easy to find. So a lot of startup pick up AWS. Like I'm building my data with their startup. Okay, I'm also using AWS for my infrastructure. And the third one, I still say the Google. Again, there are some services Google provide that are really good, but these are my take, right? This is my personal take. It can be wrong, but this is what I see in the industry. I say if you want to target top companies, top companies, when I mean the enterprise level, like banks, like a lot of top companies, that also the service-based companies can be taken into the picture, like Infosys, TCS, and all of the other things up to the requirement. But top companies who has like IPO already set up, and you can just research about their company architecture and you will find that you will see a lot of companies use Azure if they are like enterprise level. A lot of startups like Indian startups, if you see the Zepto, if you see Cred, okay, all of these guys are on AWS because it's good for startup. They give you the good ecosystem. So I'll say if you want to target startup, learn AWS. And GCP, I think I always suggest like either learn Azure or AWS, unless you want to target a specific company and they tell you that they require the skills of GCP, then go with the GCP. Okay. I just answered your question. If you are a student, then you can go with this. If you are someone who is looking for like building the architecture, again the situation is same. Think about the services that solves your problem. Okay, we will talk about the different services, but the idea is to think about like what are the services these cloud providers gives us that can help us to solve our business goal. We understood about the operational and technical architecture. Now you start thinking from this point of view. If I were to choose AWS, GCP and Azure, and if I say okay, Azure gives me these services, AWS gives me these services, and as per my requirement I can easily solve all of my business problem using Azure because they have a good service packed together. So I'll go with Azure. Like I can do a simple small project on PLC and see if that works. If it works, I can move my entire production workloads onto the Azure. Okay. If that doesn't work, there are also the concept of hybrid cloud. So you use some services from the Azure, you use best services from the AWS, you use best services from the Google Cloud. Okay, and build your system. For example, in my personal opinion case, right, I really love Google BigQuery. This is a BigQuery is a data warehouse provided by the Google. Okay, and on Azure, I really love the Databricks integration. Okay, on AWS, I really love the Glue service, which is serverless Spark workload. So what I can do, okay, glue, or also I love the S3 as an object storage. Okay, if I were to do that, I can use S3 as my object storage, I can use Databricks as my Spark workload, and I can use BigQuery as my data warehouse. So you can also do the cross cloud integration, but the maintaining all of these things are quite difficult. Again, there are some tools that can help you with that, but these are the different concepts that you can explore. I just want to throw at you right now so that you can keep that in mind. Okay, let's move forward. Let's talk about the services that we understood. Okay, now we understood, right? These are the services. So let's say if I go with the AWS and if I build my entire architecture, if I want to build my ETL pipeline, okay, how will I go with that? Let's say this is how it will happen. Okay, let me just remove this. Okay, collect, process, store and analyze, right? Data engineering lifecycle, the simple architecture that we've been understanding. I can collect data from S3, Kinesis, DynamoDB, RDS, MKS, whatever, right? This is object storage. This is the real-time data streaming platform. This is the NoSQL database. This is the relational database. We understood data is coming from multiple places, okay, where we can collect our data and easily we ingest the data and we can collect. Again, Siri, stop. Why?
Okay, I found this on the web for when we can collect Siri. Check it out.
Stop. Okay, yeah, so we can collect the data. Okay, then we can do the event processing. Okay, like say if we want to do something, let's say every time a data gets uploaded onto the Amazon S3, I want to run the lambda function. Okay, lambda function is basically the compute storage. So if we want to run the small code, you can do that. I can do this and then I can do the actual data processing using EMR, which is a Spark workload. I can run the machine learning. I can run the AWS Glue, again the Spark workload, and then I can use these services for analysis. So on AWS itself, I can build my entire data system, right? Instead of going out and picking the random tools, AWS gives you the wide range of services that you can pick from that pool and build your entire data system. Okay, this is just an example, okay, just to help you understand from this entire service tool pack, right? The AWS gives you. We understood about services. Services can be platform. They might give you the platform, they might give you the software as a service, they might give you the infrastructure as a service, right? These are the different services that they provide, and using these services I can build my entire platform. Okay, and it might look something like this. Okay, now just pay attention. Okay, don't get confused, don't get scared about all of these things. Now we're just trying to go a little bit advanced. Okay, and this is the architecture of one of the top company or top startup called as a in India. Okay, is like the fantasy betting app Dream 11. Okay, this is the architecture of Dream 11 that they have used to build it on AWS. Now if you see this architecture, you will understand it is not completely AWS. Okay, there are some things that they use from AWS, as you can see it over here. Okay, and there are some things that they use open source. And this is how the technical systems are built. This is the final version of Drive level. They went through the 3 different phases to build this particular architecture. I have posted a LinkedIn post. I will put the link in the description. If I forget, just comment it out. I will add it to it. Okay. Now let's try to understand, and also let's try to remember our data engineering lifecycle. Okay. Even though this architecture looks quite complicated, the fundamental concept, okay, the data engineering lifecycle is quite same. Okay. First of all, what did we have in data engineering lifecycle? First, we have the generation source. Now here, as we understood, our data is coming from the multiple places. So we have third party vendors. Okay, as you can see, let me just zoom this. Okay, our data is coming from the third party vendors. There is some RDBMS, so MySQL. There is some Vault DB, the where is the streams data are coming. There is a Cassandra, NoSQL database. Okay, and then there is an application. So there is a iOS and Android application, and there is a desktop dream11.com. As you can see it over here. So we understood, right? Data comes from multiple places. In this case, data is coming from the third party. Okay, data is coming from the third party. Data is coming from the databases. Data is coming from the application and the iOS. This I kept telling you, right? I kept telling you, okay, data is coming from multiple places. This is what it means. It is coming from the multiple places. Now, I want to ingest this data to my system. And most of the time for the ingestion, for the real-time streaming ingestion or just ingestion, people use Apache Kafka. Okay, Apache Kafka is a real-time data streaming platform, distributed real-time data streaming platform. So you can work on the large-scale data. Okay, and you can easily put Kafka in between to consume all of the data. Okay, it will. These are in the Kafka term. These are all of the producer. Okay, let me just write it over here. All of these people, okay, are producer who are producing all of this data. Okay, once the data is gets into the Kafka over here, okay, everything else that happens are consumer who are consuming all of this data. Okay, simple to understand. Again, we are not deep diving into the Kafka. I will be launching a course on Kafka, so you can keep eye on that, okay, in future. But data is getting produced and data is getting consumed here. Consumption is basically now what I want to do with this data. Okay, so there is a batch pipeline going over here, as you can see. Okay, this batch pipeline, first of all, we understood, right? Once the data is ingested, we need to store our data somewhere, right? There was a storage layer at below. So our data gets stored inside Amazon S3 as a data lake. Now the concept of data lake is coming. Now the concept of Amazon S3, which is a service on AWS S3, is coming, right? I've kept telling you, you can use S3 as a data lake. So I store my data onto the data lake. Okay, what happens here after this? This data goes through the ETL. Okay, as you can see it over here, this data is going through the ETL. Okay, and the ETL is happening using Apache Spark. Okay, there is some Apache Spark workload available, and then it stores our data onto the Amazon Redshift. This is a what I kept telling you, this is a data warehouse. Okay, this is my data warehouse service available onto the Amazon Rich AWS, right? This is my ingestion. This is my ingestion. This is my data warehouse. This is my data lake. Shit. Okay, this is my storage, right? This is my storage. Okay, this is my data warehouse. This is my ingestion. There's one more thing that I told you, right? In data warehouse, we put our data by transforming and making it into the structure format. Now there is one more pipeline that goes. It is called as a ad hoc analysis. Okay, and as you can see, it is using Amazon Athena, which is a Presto engine for the ad hoc analysis. And I told you, right, the looker, okay, the reporting system or the data science people can use directly data. This is a raw data that is coming. Okay, I can use this raw data as it is, okay, from the system as per my requirement, or I can also use the structured data for my requirement. So I get access to the both of the things. I can get the proper structured data also, and I also get the raw data as per my requirement. Okay, this is there. Again, understand the data engineering lifecycle that we understood. Understand now, try to connect every single thing that we have done, right? We understood about data warehouse, we understood about data lake, we understood about ETL, we understood about ingestion, storage, every single thing is put together onto the real-time system of Dream11 case study, right? We're just trying to understand the real-world architecture right now and how they use the fundamental concept in the real world. Okay, every single thing that we talked about, okay, it makes sense here, right? We have the ETL system for the ad hoc analysis, we have the structured data, we have the ingestion system going on. Okay, this is just a batch pipeline. Okay, there is one more thing, we have the real-time pipeline going over here. Okay, for the real-time pipeline, what they are using is they are using Apache Flink. Okay, Apache Flink is used for the streaming engine. So if they want to understand uh, data on the real-time basis, they can use this and analyze this. So from the streaming engine, we go to the Druid. We have the Elasticsearch. There might be some notification service. There might be some visualization available over here. Not sure about that, but this is the entire pipeline. And the fundamental concept of that we use is the data engineering lifecycle. Okay, and all of the concept that we use. So every time I store my data onto the Redshift, this is a data warehouse, I might use a dimensional modeling. Okay, after the ETL, I use Apache Spark to transfer my data. I use S3 as my data lake storage, and I use Amazon Athena for the ad hoc query. I use Looker for my visualization. I use like Jupyter Notebook for my data science workload. I use Kafka for my ingestion. These are my all of the sources. I use Apache Flink for handling real-time data streaming. This is the real world architecture. This is everything we did in the last 2 hours just to understand this particular thing. Once you have understand this, you got the good gist of data engineering. Now you know, right? Yeah, I am a data engineer because I understand this architecture and what is going on. This is the fundamental part, right? Once you understand the fundamental, you can understand any architecture. Now after once you complete this entire video, you can understand any architecture in the world, because you will know, okay, there is some ingestion going on, there is some transformation happening, there is some loading happening, there is some ETL is happening. I understand this. The tool is different, right? I can replace this tool with a Snowflake, I can replace this tool with something Databricks, right? I can use something else over here. It doesn't matter. Okay, it will work same. The feature might be different, the performance might be different, but fundamentally it will give the same output. But for their use cases, for the Dream11, they might have tried multiple things, and then they finally came up with the final architecture that is currently working for their system, right? Everything that you see on their application, everything you see on your app as a Dream11, there is a this kind of system behind that that is making it possible. Okay, it's not some magic. All right, this we understood about the AWS. Now let's understood about the GCP. Just like AWS, right? We understood that we have different services available on GCP also. Ingestion. Okay, for ingestion we have App Engine, Cloud PubSub, like Cloud Transfer Service, BigQuery, Cloud Function. Now I want to tell you this. Most of the cloud providers has the similar service available. For example, there is a data warehouse available on big GCP called as a BigQuery, which is same as Redshift on AWS. Okay, there is a cloud function available which is same as AWS Lambda. Fundamentally, they give you the similar platform to perform your workload. The name is different, the feature is different, the cost is different, but fundamentally it is same, right? Just like we have the cloud storage, this is basically the S3 of AWS. Cloud storage, object storage. We have the cloud SQL. This is the RDS. This is a relational database service that we talked about, right? BigQuery is the data warehouse that we understood. Data prep is same. Data proc is same as EMR. Okay, Elastic Map Reduce of AWS. So if you understand, okay, services are same. Like most of the cloud providers have the similar overlapping services. It's always choosing the best service for your use case. So for ingestion they have these many, for storage they have this many, for process they have this many, and for exploration, again the concept of data engineering life cycle. I have to ingest something, I have to store something, I have to process something, I have to serve something. Okay, this is the simple architecture on the GCP. Same fundamental concept applies. I have data coming from multiple places. I ingest this data, I store this data. There is a pipeline that is running right now. Again, I store some data, I store the data onto the BigQuery. Okay, and then there is some privacy on Oracle Cloud, like identity campaign running. This is like the end user part, right? Customer platform there is there, and data destinations such as web apps, customer service, marketing, messaging. Same fundamental concept. Data source, collect, process, store, and give to something. This is where entire data engineering is happening, right? I get the data, I ingest it properly, I store it, I process it, I give it back. Okay, now this is done on GCP. Again, let's look at it on the Azure level also. Okay, these are the developer services. We have the compute. Okay, for compute we have virtual machine, cloud machine, batch storage. Again, same. We have the web mobile app. We have for the data. We have the SQL database, Redis cache. We have the SQL data warehouses. That is also available for analytics. We have the data lake analytics, data lake store, stream analytics, machine learning, data factory. Okay, IoT we have, media we have, identity access we have. In my opinion, Azure has as a data engineer, Azure has the very good service for the data engineering workloads. Okay, they have like three services that I really like on the Azure. So one is the Databricks. Okay, I really like Databricks because it is properly integrated on Azure, and Databricks is basically the environment to run Apache Spark workload. Okay, second is I like Data Factory. Okay, Data Factory, and third I like is Synapse Analytics. Okay, most of the service, and there's a new service available I haven't explored called as a Fabric, Microsoft Fabric. It is basically the combination of these multiple service where you can do entire thing at one place. Okay, specially designed for data engineering workloads that makes your life much more easier. I have a project on this on my YouTube channel available for free. Okay, I will put the link in the description. If I forget, do let me know by commenting. I will put that. If you want, you can explore that. I also teach about all of these things on my courses also. So we do have a projects available onto that. You can explore that onto the by going onto the website. Okay. Now this is the architecture side of the same thing, just like AWS. Okay, I can replicate this entire architecture on GCP also and also on the Azure. What I have to do is basically I will just have to replace. Let's say if I'm like replacing this entire thing onto the GCP, what I will do, I will instead of S3, I will use cloud storage. Okay, instead of Redshift, I will use BigQuery. Okay, I can put the data proc here. Okay, I can also put the BigQuery here if I want. For streaming engine, I can also put the PubSub and data flow. Okay, um, what else? For the Kafka, I can put the PubSub, but I'll say I'll go with the Kafka. Kafka is best. Okay, Looker is good. This is good. Everything else seems fine. So I can also convert this my AWS architecture to GCP. The performance might be different, the costing might be different, the UI might be different, the integration might be different, but I can do that. Okay, I can also do the same for Azure also. Simple. Okay, and this is what the Azure architecture says that, right? What do we have? We have the customer stream data, we have the customer batch files. Okay, we are ingesting this particular thing and we are just adding this onto the ADLS, which is Azure Data Lake Gen Storage. It is a service available from the external source. Okay, now there is a data factory running. Okay, it is like data is coming from on-premise sources and these are some stream data, goes to the data factory, it gets entered into the raw zone. Okay, the raw data is getting entered. We use Databricks over here to process this raw data and store it onto the processed, okay, process folder. After that, it goes to the analytical zone and it goes to the SQL pool, which is a SQL data warehouse. Now from here, customers can use this for to build the Power BI dashboard, get the insights. Okay, and it can be also integrated with the desktop application if needed. Same concept: collect, ingest, store, transform, serve, and use it. Same, everything is happening. And there are some undercurrents, as you can see. We are using the Azure Key Vault to properly store our data, like securely store our keys, log analytics, Azure Purview. We have Azure DevOps to properly operationalize our entire integration for the scripts. So these are the different services that can be used together. So these are the three different pipelines that we have used till now. Okay, I just showed you using AWS, I just showed you using GCP, I showed you using the Azure. Now let's look at the modern data architecture, right? This is also modern, just especially built on the cloud. This is the modern data architecture, right? It's a modern data architecture is basically there are new companies that are coming in the market and they say that okay, the tools that you guys are using is old now. They don't work with the new they are not efficient for the new data workloads and the new volume, and the approach is very old. Okay, and I, as a new startup, I am a modern data company. I will make your life more easier. So instead of you doing the ETL, remove the ETL. Okay, I will say directly load the data into my product, okay, and I will directly transform it for you as per your requirement, so that you can directly, you save time about the ETL and you directly start querying the data. This is what the modern company says. They, all of them have the different requirements, so they directly give you the integration between your different sources. As you can see it over here, right? uh, I have the different data coming from the sources, like it is coming from Stripe, Google, PostgreSQL, Google Play. What they say, I have the integration with all of these different sources. These are the application, right? Fivetran, Airbyte, Stitch. Okay, these are usually used for the ingestion. You can also use Python and Spark, which is like the also the modern way. Before this, we used to use the Hadoop and all of the other workloads. This company comes and say, okay, use our system, because we have like made this, all of these things easier for you. Directly connect with these multiple sources, we'll pull the data for you, and we'll directly load it onto the data warehouse, so that you can do everything as per your requirement. There is a new tool called as a DBT, data build tool, that is used for analysis. People say that it is going to replace SQL. Not going to happen. Most of the times, a lot of companies comes in and want to replace SQL, but still SQL is the king of data, right? You should always learn SQL. DBT is also gaining a lot of popularity. It has like it, you can divide your data into the multiple things. So multiple, you can divide your data into the multiple stages. The thing that I told you about, like ELT, right? ELT, we are doing ETL till now. We extract, transform, and load. Now we will do ELT, which is we will extract our data and directly load our data into the data warehouse. Okay, it can be Snowflake, BigQuery, Redshift, Databricks, doesn't matter. And we will divide our data into different landing zone. Okay, this is a modern data architecture, right? We create the landing area, we create the staging area, we create the warehouse layer, and we create the mart layer. Same fundamental concept. If you see that there is a data where there is a data mart, there is a data warehouse, there is a object storage, and there is a landing area to store the raw data, right? I store my raw data, I store the staging area after some transformation, I store my data into warehouse, and this is my mart layer. This, all of these things you can create inside the DBT, and directly you can store your data onto the Snowflake, Redshift, and all of the other things. Same thing. Then it can be consumed by the BI people, machine learning people. They can build dashboards on different tools. You can do the analysis on different tools. There is also concept of reverse ETL companies are using. That basically means I have transformed my data. I can put back this data onto the source system and get more insights from the transformed data by ingesting that data back to the system again. This is a totally different concept. Um, I'll cover it in some other videos, but there's also a concept of reverse ETL that we also saw it on the data engineering lifecycle. Okay, modern data architecture. We understood about the GCP, we understood about Azure, AWS, and using modern data tools. Combination of these different tools and AWS and Azure, you can build the modern data platform. Now, again, we talked about this here. We have like thousands of tools available, right? How do I decide which tools is best for me? First, I look at the business requirement. Uh, does this solve my business problem? Yes. If it does, then I should use that tool. If it doesn't, then it should be reversible. So, okay, so I can easily remove this. Let's say this tool is costing me too much, okay, and this is not really even solving my problem. I can directly remove this and I can go with this. If this tool is also not working, I can directly go with the Spark case, because it is going to work, because it is open source, right? All of these things are going to cost you. Spark is going to cost you for the server. So you have to choose between, this is easy, this might be quite difficult to set up. So as a company, if you're a startup, people usually go with using these things because it saves time. Okay, you have the money but you want to save time, so you can directly go with this will solve your problem. This will also solve your problem. Okay, whatever solves your problem, whatever helps you to reach your business goals, you can go with that. Okay, now I just want to take a break, so have a water and I'll come back in 1 minute. All right. Till now, we have understood a lot of things. Now, this is kind of like the end of the video. And again, I can't cover every single thing, but I want to leave you with some of the important tools that you can learn about data engineering and some of the concept uh, at the end. Okay. So that is important for you for your career. So let's start with that. Okay. Important tools for data engineering. Now, first of all, if you want to become a data engineer, you have to learn few things. First of all is the programming language. You have three choices: Python, Scala, and Java. Now, if you want to learn any programming language, I always suggest start with the Python. Okay, easiest to learn, mostly used by industry, because if you want to write this Apache Spark script, if you want to write the Kafka ingestion engine and all of the other things, Python has a lot of packages that makes your life much more easier. And even industries use Python for all of this workload. So you should always go with the Python. If not Python, you can also go with the Java. Java also has a good support, because most of the open source framework like Apache Spark, Hadoop, all of them are written onto Java, okay, itself. So you can go with the Java also, but my suggestion is to go with the Python. Okay, important for you to learn. In Python you can learn about like basics of Python, such as variable operators, basic data structures like dictionary, list, all of the other things. Important things to learn is that you should learn how to work with the date and time format, how to uh, like there's a package on inside the Python called as a panda, so you should learn how to transform the basics of data, how to work with the different file formats also, like CSV, JSON, Avro. Okay, uh, this is you can learn on the Python. I have already created the detailed roadmap onto this, so I'll also put the link of that particular video in the description. If I forget it, do let me know, I will add it. Okay. SQL, again, SQL is the backbone of your data career. You cannot skip this. This is how you communicate with the databases. We understood about everything. So you have to learn SQL. This is non-negotiable. Okay, you cannot skip SQL. You cannot skip Python. This is the foundation. So you have to learn this. After this, you can understand the Linux command, because you will be working with some of the cloud providers or the Linux machines. Most of the like 80 to 90% of the servers online runs on the Linux server only. So you should learn to interact, because it doesn't have the GUI, right? You don't have the graphical user interface. You will be accessing it you by using the terminal. You can learn about this command like cd, how to clear, how to copy, how to exit, how to find something, how to view the file. Okay, all of these are the different commands that you can learn. You can just you can just search on the YouTube basic Linux commands, and you will get a good tutorial. Okay, now we have a data warehouses. Again, you don't have to learn all of the data warehouses. Okay, you can learn. You have the AWS Redshift available, we have the BigQuery, we have the Hive available, Synapse Analytics, and Snowflake. My suggestion is either learn Snowflake, because this is not dependent on the cloud platform. Okay, this is cloud independent, so you can learn this, and also this is highly demanded in the market, so you can easily learn this and add it in your skill set. Very highly demand. There's one more that I love personally, which is BigQuery. Okay, because I have worked with the BigQuery for last 3 to 4 years, and I've really enjoyed this service. So this is my one of the big, because this is one of my favorite service onto the GCP. So my suggestion is that go with the Snowflake, because this is cloud independent. Okay, if you are working with a specific cloud, you are anyway going to learn. Let's say if you are learning AWS, you are anyway going to learn about Redshift. If you are learning BigQuery, you are anyway going to learn about. Or if you are learning GCP, you are anyway going to learn about BigQuery, right? So my suggestion is to just learn Snowflake, because you will learn about these three by learning about the cloud. Hive is an open source. Not anyone uses it. This is just the use for meta store for Apache Spark or Apache Hadoop workloads. Okay, as a meta store to store some of the information, but not really recommended to learn it separately. You can just learn the basics, and in case if you have the requirement, then you can learn it on the go. Right, it will take you like 1 to 2 days if you have the basics clear. Okay, data processing. This is interesting. Okay, for different workload we have a different you can use Apache Spark for batch and streaming. You have to learn Spark. This is very important. Okay, so you cannot skip Spark also, because this is used by top companies to process big data. You also have to learn Kafka, because this is very important to process real-time data. Okay, out of these three, I say learn Apache Flink for real-time analytics. You can use Kafka for streaming. You can use Flink for analytics. There is NiFi and Apache Beam also. If you learn GCP, okay, you will automatically learn Apache Beam also. So my suggestion is learn Apache Spark, learn Apache Kafka only. Not really right now. If in case you have to use it somewhere, you will learn it on the go. Okay, just add a Kafka and Spark in your skill set. Data orchestration. Okay, we have many tools available. Out of this, you should use Apache Airflow, one of the highly used tool in the market. Okay, we all have these modern data tools. Okay, these tools takes roughly 30 minutes to 1 hour to learn. Okay, if you have your fundamentals clear, right, you can just watch one video and understand more like 80 to 90% of the tools, right? It is Very simple. I learned about Maze in just 1 hour. Okay, it didn't take me to learn more than that. So there is one project available in our channel also. So if you want, you can learn that. So these modern tools are created to make your life easier itself. So okay, so to learn Apache Airflow is quite complicated, right? It will take some time to understand the gist of it, and we have a course on that. So I'll tell you about this right now. But we you can learn about Daxter, Maze, and Prefect within 1 hour. I don't think that will take so much time. Okay, and this is the modern data tools available. Okay, these are all the modern data we call is a stack. Okay, these are the modern data stack. Okay, as you can see, we have like for ingestion, I think this is Airbyte and this is 510 for ingesting data. For data storage, we have the BigQuery, Snowflake, Databricks. For BI, we have the Looker, Data Studio. Data transformation, we have DBT. Data orchestration, right? If you want to orchestrate your entire thing, we have the Airflow. There are some DP framework, GitLab. We also have that. What is the data quality and metadata platform? We have the Open Lineage, Datafold. Again, you can just search about the tool name and you will get what they do. Okay. When we talk about modern data stack, it is really important to just understand why this tool exists in the market, like what problem does it solve. So in this case, Fivetran solves the problem of data ingestion. It takes data from one source and it puts the data to the other source. DBT gives you the modern transformation. Okay, DBT gives you the modern data transformation. Airflow is for the orchestration. So if you want to orchestrate and build a data pipeline, you can do that. This is for the data quality and the governance. So these are some of the tools available. Just search online and you will find the plenty of resources. All right. Uh, Now I want to cover these individual things, right? What do you need to learn about the Python? What do you need to learn about the SQL? What do you need to learn about the data warehouse, Spark, Apache Airflow, and Kafka? Okay, so I just want to cover about these individual things. What can you learn? Uh, for this, again, I already have the roadmap available, but I'll just quickly go through this part. Let me just open this, right? This is available here. So learning Python is one thing and learning Python for data engineering is one thing, right? You can learn Python for free online, but if you want to learn Python for data engineering, you have to learn certain things. I'll just show you quickly because I have it on my website itself. So this is my Python for data engineering course. I'll just go through the modules. So you don't have to take this course, but if you want, you can learn these things for free online also. I have created courses just to give you the structured learning approach so that you don't get distracted. Okay, so you can learn the basics. All of these modules are open, so if you want, you can learn it. You can start with the string. You can learn about the numbers. You can learn about the data types. You can learn about the data structures like list, dictionaries, sets, tuples. Okay, you can learn about the conditional statements like if else. You can learn about the loops, for loop, while loop. Then you can go to the intermediate, such as understand the Python packages, how to import them, list comprehension, exception handling. We have to how to work with the text files, how basics of lambda function and object oriented programming. There are some advanced concepts such as numpy, understand about the numpy package, pandas basics, how to use pandas for the transformation. Then working with the datetime format, very important if you want to work as a data engineer. How to work with the different file formats like JSON, CSV, Excel, Avro. Okay, and these are the basics. In my course, I have included one project for the Python. Okay, this is like Spotify data pipeline project. I'll tell you about this part at the end. Okay, if you're interested. Then we have the SQL. Inside SQL, what you have to learn, you can pick one DBMS. We are going with the Postgres because Postgres is open source and easy to learn and easy to set up. Learn about the important keywords of SQL such as select, insert, update, and all of the other things. Learn about the data type and how to create tables, how to create database, different types of queries, and available. Okay, like DML, DDL, like data manipulation language, data definition language. You can learn about that. You can learn about the operators in SQL. Okay, you can learn about alter query, database constraint, primary key, foreign key, asset properties, normalization, insert, update statement, joins like inner, left, right, after, cross join, order by, group by, having clause, aggregation function like min, max, all of the other things. Also understand the advanced topics like subqueries, common table expression, window functions, analytical function like rank, dense rank, row number, lead, lag, CTAS function, temp table, casting, working with date time, case statements, stored procedure. Learn about the data modeling. We understood about the basics of it. It is like ER modeling and data model. So learn about that and just try to build your own data model. Like you can pick one company name like e-commerce or the Instagram or any company like Netflix, and you can build a data model as a project, right? It looks something like this data model, as you can see it over here. This is like Instagram data model. Okay, this is like e-commerce data model. Okay, after this you can learn about the data warehouses. Okay, in data warehouse, you can start with the basics, understand the data warehouse, what data warehouse is, understand the OLTP versus OLAP. We understood about this. Understand the difference between data warehouse and data lake, ETL process. Learn about the Snowflake, like basics, just create the account on Snowflake. We have a tutorial on Snowflake also on YouTube channel. Learn about the dimensional modeling, so deep dive into dimensional modeling, which is understand what is dimensional modeling, understand the fact tables, dimension tables, understand between the star schemas, Snowflake schema, types of fact tables, how to create fact tables, factless, surrogate key, date dimension. So these are the things you can learn about the dimensional modeling. uh, you can learn about the SCD, slowly changing dimension. You can learn about ETL. These are the concepts that you can cover onto the Snowflake database. Okay, like stage copy, file formats, handling unstructured data, how to work with them, virtual warehouses, caching, clustering, storage integration, snow pipe, time travel, how to undrop things, how to recover data from past, types of tables, zero data cloning, data sharing, materialized views. There are the concepts that you can just think. These are the concepts that you can also learn on the Snowflake, right? I'm just trying to give you the overview of the things that you can learn. Uh, for me, I have created this like one step by step roadmap. I'm still building this entire thing, so you can go to this website, Data Vidya, and you will see like I'm trying to build a course. Like first is the Python, then second one is the SQL, third one is the data warehouse, fourth one is the Spark with the Databricks, fifth one is the workflow orchestration. I'm currently working on the Kafka course. Okay, and then there will be a dedicated cloud computing course in the future. Okay, so after this we have the Apache Spark. This is very important in Apache Spark. Understand what is Apache Spark, why do we need Apache Spark, understand the architecture, understand about these concepts such as data frame, transformation, action, lazy evaluation in Apache Spark. Okay, learn how to install Apache Spark, very important. Then we have the this deep dive structure API. In Apache Spark, we have two things: structure API and the lower level API. So learn about the structure API, basics of it, how to define user defined function, data types of Apache Spark, data sources, partition, bucketing, how to work with the external tables. Then we also have the lower level API such as understand about the resilient distributed data set. Also learn about the production application, how to run Spark on the cluster and the Databricks. Okay, these are the topics that you can also cover. Like you can just screenshot this or you can also go to visit the data with their website just to get the understanding about the module. Okay, you can learn all of these things for free online. Okay, you don't have to really go through this because I'm just going through this because this makes this entire thing easier to explain, right? For Airflow also you can just go through this section. Okay, what are the things that you need to cover? There are few concepts that are important. Okay, and then you can build the projects like this. So I just quickly showed you like what are the different topics that you can cover from the website. So instead of writing each and every single thing onto this page, that will just increase the time of the video, and I'm also feeling pain inside my throat because I've been recording this thing from last 3 hours. Okay, so I just quickly showed you that particular thing. These are the two different topics that I also wanted to cover: the data security and data masking. Okay, data security is important. We talked about this at the initial stage. In data security, we have to take care of the three things: confidentiality, integrity, and availability, right? Ensure your data is accessible only to the authorized users. So you don't give access to your data each and to every user. Only the authorized user should be able to access that. Integrity, basically maintaining the accuracy and completeness of your data. So your data should be accurate and should be able to provide the final value. And availability, that your data is available to authorized users whenever we need. Okay, these are the three important things inside the data security. These are the measures you should take. First, you should encrypt your data. Okay, encryption should happen so that if it goes through the network, the other people should not be able to understand what the data is. Access control, only give the data for the specific user. Data classification, classify your data like if this data is confidential or not. And the security is like secure the data onto the network level. The one concept that I wanted to talk about, the data masking, okay, that I talked about on the governance level. So usually this happens is that uh, you have the employee table. Okay, what you have to do is like there are some governance restricted, there are some regulations by governments that they say that you should not store the information, the sensitive information about the users, right, like credit card, address, social security number, and all of the other things. So when you do store it, make sure you mask them. Masking is basically a technique. So basically this is the ID of the user, right? What do I do if I want to mask this? I will replace this with some random number. Let's say this is my social security number. Okay, what if I do, what if I, this is my social security number, what will I do? I will just mask this with something like this, XXXXX, and I will just reveal the last 5 digits like this. Okay, you can also do this for credit card. This is called as a masking. Okay, now these are the different file formats you can use for big data. These are common: JSON, CSV, Parquet, Avro, and ORC. Every file format has their own use case. I don't want to go deep dive into this right now. Cover some of the things on my courses, or you can just Google this and you will understand the most of the things that you want to learn. Okay, so till now we have covered a lot of different things. I might have missed some of the topics, right? So I cannot cover every single topic in single video, right? In single video, this might be around 3 hour video. Okay, I'm not sure if once I sit and edit this video, I'll get to know about the timeline. So but approximately this might be like 3 hour of the video, 3 hour video. I might have missed some of the topics. So what you can do, you can comment down, okay, the topics that you want to learn, just the fundamental topics, right? Hands on, we will have the projects for that. Just the fundamental concept that you want to learn. What I will do, I will club all of these topics inside the part 2, and I will create like the video like this, like long 3 hours of the video that you can watch. Okay, now you understood about all of these things. Now if you like the way I teach, and if you really want to learn about data engineering, you can go to the website. I will put the link in the description. Data Vidya slash combo pack. On this combo pack, you will get the 5 courses, because till now only 5 courses have launched. I'm currently working on to the Apache Kafka course. As you can see, we have a notes available for that also. So you will also get the access to this kind of notes if you enroll into the course, because I create all of these kind of notes by myself. Okay, so that you can revise at any times that you want. Okay, so you will get the access to all of these notes. So this is my zero to hero data engineering combo pack. It comes with the 5 courses now. In future, when they launch the course, you can enroll into that course separately, and I will also create the new combo pack. So if you see the new combo pack while enrolling this, okay, at that time you might see the Kafka also added into this. Okay, in this course you will get around 14 plus projects. I will teach you, okay, how to make one project the best project. It is like the step-by-step approach you will get. So as you can see over here, in your Python for data engineering project course, you will build this particular project. Okay, in Snowflake you will build a similar project, but instead of using the glue crawler and catalog and Amazon and Athena, we will be using the Snowflake over here. Okay, now in the Spark course, we will replace this Lambda part, okay, for the Python, and we will replace it with the Apache Spark. This way you will understand how to evolve one single project and how to plug and play with the different tool set. This you will learn in the entire combo pack, right? How to take one simple project and make it the best production level project as we go forward. Okay, we'll start with the basic, we'll replace some component, we'll add Spark, then we will also add Apache Airflow. Okay, inside the Airflow, we will use the same project, and we will use the Docker and Apache Airflow to orchestrate this entire pipeline. We will also create a similar project just using Apache Airflow only. Okay, so as you can see, one simple project, we will create it like 5 to 6 different ways, right? So that you get understanding of the data engineering is not just about using tools, it's about the fundamentals. The fundamentals that we understood, you will actually implement all of these things over here. Like this, you will also get the projects on Apache NiFi and the real-time data streaming. And there's one project available on the Twitter data analysis, is also available on YouTube. There is a project available on GCP also. There's one project on Azure. I think GCP project is there's a project available on Azure over here also. GCP project is also available. Let me just show you over here. Yeah, this is a crypto data pipeline project available onto the Apache Airflow course. Okay, so you will also learn about Azure, you will also learn about AWS, and you will learn about GCP just by doing these 5 courses. And then in future we will have the in-depth courses on individual cloud also. So you will get like 14 different projects over here. Okay, 5 courses, you can get the information about all of these different uh, over here just by clicking this. Okay, these are the reviews from our students, okay, previous student, and they have built their own projects till now. So if you want to check, you can also go through this and understand like they have built some amazing projects. You can just click over here, okay, and you will be redirected to the link of the project. I hope this is working. Okay, or you can go here, this also. Yeah, as you can see it over here, this guy actually built the Airbnb project using the Azure. So just like this, you can build your own project and put it on your resume also. This course is for everyone, like cloud engineers, web developers, data engineers, technical consultants. So it doesn't matter who you are, you can learn this. What you will get from this course, you will get the code template. Okay, you will get each and everything about the code that you can use. You will get the access to the interactive Discord community. You will get the support if you are stuck with any doubts or any errors. You can ask it on the Discord channel. Someone will help you out, or I will help you out. Or in future, you will also get the early access and discount to the, like, huge discount to the future courses, right? So let's say if I launch the Kafka course, you will get the you will get the huge discount for that course also. These are some of the reviews from our students, so you can go through that. These are some of the commonly asked questions, so you can also go through that. So if you are interested, you can go through this. If you are not, you can also learn by yourself. Okay, my voice is breaking, but the best part about this particular data engineering roadmap is that every single course is in depth, so you will learn about most of the things. Most of the bootcamp available in the market just give you the surface level knowledge. So if you go to the any website that sells the data engineering courses, they teach you all of these things by each and every module. They might have like 2 to 3 videos added to their module, and they are done. I will give you all of these things in detail, and with that you also get the access to the notes like this. Okay, if I show you here, if I show you the Obsidian, you can see this interactive graph environment. You can see the Apache Spark topics available here. Okay, Apache Spark, what are the different topics connected. These topics are also connected between different courses also. So partition or the transformation concept is also applied on the data warehouse and the Apache Kafka. So as you can see, data warehouse, you can see the SQL, you can see, you can also go with the basic topics. So all of these are like the topics cloud. You can easily interact, you can directly search the specific topics, such as I want to learn about the partition. Okay, partition. Okay, and I can know that okay, partition is available over here also, over here also. So I can easily search and learn about the different things. Okay, after this, there's one more thing. What is it? Where this is, okay, you will get the detailed notes. So if I were to show you the notes, let's say there's the basics of Docker. Okay, you can go and search about it. Airflow basics UI. Let's say if I want to like writing my first tag, okay, this will give me the each and every single instruction, right? How to write my first tag, what are the codes, everything that I have to do, every single thing you will get here. Okay, every single thing. So this will make your life so much easier that you don't get distracted by looking at different courses or different resources. You just stick to one single path and you can become a data engineer. So this is what I wanted to show you about my courses. If you're interested, just check the link in the description. If you're not, totally up to you. uh, you can use multiple resources. I also have the free resources available, so you can also check that on my YouTube channel. This was everything about this video. This is now almost 3 and 3.5 hours I'm recording this video. Hopefully the recording gets stored so that I don't have to re-record this entire thing. This was everything for this video. If you are watching this video till now, okay, do let me know by writing the comment, okay, because this is a long video. Also like this video because I put a lot of hard work, and also comment something, share this with people so that all of the people can get take advantage of this and grow in their career. That's everything. Thank you for watching this video. I'll see you in the next video. Thank you so much.